Hello, hello, hello. Good morning, good evening. It's stream number 130. So today I'm going to work a bit on making a class in C++ that has both high precision and accurate clock for real time. And I started working on this yesterday, and I collected some data. I meant to collect data overnight about it, but silly me, my habit is to just turn off my computer and when I'm going to bed, and I turned it off, not thinking, and so I only collected about 6 hours of data. What is that? Whatever 35,000 is in seconds. Oh, actually I got 9.7 hours. Okay, anyway. And this wasn't exactly what I predicted. I kind of thought I would see a step function. So what this is charting is the difference between the clock that I'm making and the wall clock, which is in seconds, and predicting that the frequencies wouldn't match and that eventually the two clocks would slip from each other by whole seconds. I expected a few steps one direction or the other. Instead, I saw one giant step, 3 seconds at some point, and that's about it. So I'm going to try a little bit of a different approach today. Instead of using the C function time, which gives you the time in whole seconds, I'm going to try to use the C++ system clock, which apparently has microsecond resolution. So that should allow me to kind of see a gradual slip, even if it's sub-second, over a short period of time. And then I can work on making a frequency adapter and lock my clock to that system clock. So I was also thinking about, if the system clock has microsecond resolution already, maybe I don't even need to do all this special clock thing. Well, we'll see. So right now, here's the naive implementation. Hey, the Rally Monkey. Look at that, you got a gold gear now. How are you doing today? That's okay, Rally Monkey. I understand. Yeah, so here's a naive implementation of a frequency locking clock. It doesn't frequency lock at all. It is just taking the wall clock from the C standard library and using it as a base from which to add the an offset, which is computed as the using the high precision. Is it called the high precision? No, it's using the performance counter of the CPU. I'll show you the implementation on Windows. Query performance counter. And we use query performance frequency to figure out what frequency it is so we can convert it into seconds. So it's another clock that's not locked to the wall clock or real time, but it's pretty close. So this gives us high precision in an offset based off of a real-time wall clock reference that we grab. The problem, I think, is that it's just not frequency locked, and so we'll eventually slip. And that's what actually happened over 9 hours. It slipped by 3 seconds at least, but it did so in an unexpected way. It waited for a while and then slipped a whole 3 seconds, and then instead of stepping, which is what I expected to see. So anyway. Yeah, I understand. Sorry to hear that, Rally Monkey. A lot of catching up. Oh, you don't have to catch up. You can jump forward, right? Okay, so yeah, the plan today is to basically to fix it so it's frequency locked. I want to gather some data first. So first, I try to gather data proving. Oh, I'm bad at typing this morning. Proving the frequency really is off. And then write a code to discipline the clock. So disciplining the clock, I think this is the right terminology. If you look up NTP, Network Time Protocol, they talk about taking a local crystal oscillator and compensating for its frequency difference from real time. I think they call that disciplining the clock. So the idea is you take one clock, which is off in its frequency, and you look at a second reference clock and basically measure the difference in how fast they're slipping away from each other, and then use that as an adjustment factor to tune basically the values you get out of the original clock. So we're going to be doing that, and because we're working on time stuff and I had these on my to-do list, I thought, hey, let's go ahead and do this. I wanted to use timestamps in all my diagnostic messages so that I can actually figure out from a diagnostic log when stuff actually happened in real time, what the time and date were. And then somewhat related to this are the collecting of messages in the orchestrator. If I were to run that here, well, that's interesting. I didn't expect to see that. But let's just clear this. You can see whenever I start the cluster, all these time references are from when I actually started it, don't have any real-time significance. Like there's no date or time, so I'm going to fix that to show an actual timestamp here that we can convert to date and time. And all this printing actually does incur a speed penalty. And I think it has to do with actually printing to this console window, because if I redirect the output of this to a file, it's much faster. So I thought to compensate for that, in case I am looking at it through a console, is to offload the reporting to another thread so that it doesn't slow down the reception of messages. And then another problem I have is that this is collecting diagnostic logs from 3 different servers, 10, 11, and 12, and they can arrive out of order because of different delays. And so the messages that we're printing might not necessarily be in the correct order. I don't see a way to demonstrate that here, but sometimes it's pretty obvious. You'll see something like a follower server saying, hey, I heard from the leader, and then somewhat later you'll get a message saying the leader is going to send that message now. It's like, well, they're out of order, and they're out of order because of the way we're collecting them together here and printing them. Because of different delays, they could end up out of order. So I thought I would you have to slightly delay them in order to sort them by time, so to print them in order. And the sorting really will only work if all 3 servers are using a disciplined real-time clock. So that's why this is sort of a prerequisite for this. So anyway, I think the first thing I want to do is get a better chart and not have to have it run 9 hours. So my idea was to, instead of using this time function, which gives us time in seconds, to use a C++ system clock. I was reading about this in the interim between streams. So system clock. So right, it returns a time point representing the current point in time. Interesting way to describe it. So I need to include chrono and then use standard chrono system clock now. And then I can make a duration of whatever unit I want by subtracting 2 time points. So that's what I want to do here. So include chrono. And we're not going to use time h anymore. So wall clock will be... Oh, wait a minute. I'm doing it in the wrong place. I want to do it in Bob, my little test measurement program. Where are you, Bob? Here you are. Right, so here we'll remove time, and we already are including chrono. I need to make sure I'm sitting up straight in my chair. Okay, so initial time will be standard chrono system clock now. And then wall clock time here. It's the same thing. And then wall clock difference, we actually need to give it a type, I believe. Well, actually, let's see if I hover over, what does it do? It's some kind of default units. So I really do want to specify the units. Chrono duration double. I believe it is in seconds, but we'll soon find out. They make special elite chairs for streamers? Yeah, but mostly that's for gamers, right? If they had an elite chair for programmers, I might consider that. Okay, so the problem here is what? We can't compare doubles with duration doubles. Oh, there's a count. Right, so if I do this dot count, then we get the drift. Okay, let me try that. And then using a shell. Oh. Alright, I had started up a bunch of other NPM stuff since it takes so damn long to start them. I figured I'd start them before I start streaming. Okay, let's use this shell all the way over here. Build. Oh, 9K clock for over 9,000. Bob. Okay. So now it's running. Every second it's going to do a report. I was hoping to see what is microsecond drift after a while. Maybe I need to run it for a while. What I should also do, I'll let that run for a while. In the meantime, let me do that twice at the very start here. Oh, actually do it. Oh, no, I don't. Yeah, let me run that twice and print out the difference. Just to see what the precision really is. So let's call that wall clock time 1 and 2 and printf. Smallest difference in wall clock. And that is wall clock time 2 minus time 1 count. This hasn't accumulated error, or the precision isn't very high. I'm wondering if it's a precision problem. Okay, printf needs... Was this not the right unit? Oh, yeah. I need a standard chrono duration double of that dot count. Okay. 0. Okay, that's not good. How about we will... That doesn't need to be static. I know what I'll do. That's double. Actually, no. What is that type? Standard chrono time point system clock. Okay. Standard chrono time point. Standard chrono system clock, right? Yeah. So we can just measure it until it changes. So do wall clock time 2 while wall clock time 1 is not equal to wall time clock 2. I hope I can do a comparison. Sure would help if I spelled while correctly. Okay, that didn't help. I guess I'll need to do this. While that is equal to 0. It's still printing 0. Okay, do I need to print more resolution? It's not billed correctly. Okay. It's printing 0. That looks an awful lot like 0. I wonder if it's just rounding. So how would I print out more? It would be like point some ridiculous number of digits. Really? So it's 300 nanoseconds. How many times do we have to run to let's make a count. How many times do we have to loop before we got that? 4 loops. 10 loops that time. 6 loops. So let me just print out this difference with more digits. That's up here, right? Yeah. How many do we want? That's 10,987.7. Gosh, I was hoping it would slip at least a little bit. Maybe it is there. Oh no, it jumped back to 6 again. It's going to 8. It's all within the noise threshold, really. If I see it move to 8 consistently, then I'll know it's slipping. No, it's all within the noise, I think. Or maybe this whole thing is a wild goose chase. If this never diverges, that means a performance counter is locked to real time, which I really didn't expect. I know what I'll do. I will T that. And let that run for a while I work on something else. Actually, if it has that great precision, maybe I don't even need to make a clock. I can just use system clock. Although one problem with system clock I read is that it's not monotonic. It may not be monotonic. On most systems, the system time can be adjusted at any moment. So that might be one reason to make my 09K clock anyway, is to make mine monotonic. Basically, it means it always moves forward. So it could be based off of the system time in frequency locked to it, but if like the system time were to jump back, for example, we could keep our clock and just only use the system clock for its frequency, not its actual value, after we first sample the initial time, that is. Or we can accelerate towards the correct time, like do time correction stuff. Kind of hard to describe this without having like a diagram. Yeah, this is not what I expected. It's staying locked to the microsecond. Anyway, if I wanted to set timestamps in diagnostic messages when they're published, what would I do? Probably when we collect them, right? Let me look. Where do we collect diagnostic messages? That would be in the main program, I think. I have this diagnostic publisher that reports the standard out and standard error. And we also report it back. This is the mechanism through which it gets sent to the orchestrator. So if at this level we sampled the time and we sent it, we included it in the message, perhaps? Or no, hold on. This publisher we can change, right? This guy. Instead of using this guy, I can make a custom one. Right now it's using this. We can make a custom one that doesn't do that. Right, and then we can compute the time, send it to our custom reporter, and send it through here by changing this interface. Searchy, searchy, search. Well, how's the little clock thing going? It's not really slipping at all, is it? It's all within the noise. Although I'd like to chart that to know for sure. Okay, anyway, here's where I need to modify this. So I don't actually need to do test-driven development here, but this is all diagnostic stuff. Asynchronously report to give a diagnostic message to all orchestrators. Hey there, Nui. Working on diagnostics and time tracking right now. So I'm going to include a timestamp here. Actually, why put it in the? I guess it's arbitrary which position I put it in, isn't it? This is the time in seconds since the Unix epoch. Midnight UTC January 1, 1970. When the message was captured. Alrighty. We'll put it here. And we will include it in this capture to be deferred later. And so you need to include it here. Timestamp, right? Which means I need to add timestamp to this structure. And document it the same way. There we go. Okay, and then we encode it. So there's a 2JSON. So here we go. We can include the timestamp. And then it gets pushed off, and then it gets delivered. Oh, okay. I did have some tests that involved it, so we need to update the tests. Let's do 1, 2, 3, 4, 5. The time. Oh, it's at the front. That's right. Probably gonna have to do this in all of these places, right? No. Okay. Yeah, so we're gonna include timestamp. I love test messages like this. Sender mom. Level 7. Please call more often. Call your mom. Okay, second log message. Let's make it 6.4. This first log message timestamp. And second. And then we see what we expect. Okay, good. Looks like I have to do the same thing over here. Another test. There we go. Change all the places. Oh. Okay, a couple more places. Yep. Get through this as quickly as I can. Actually, I don't know why I'm hurrying. This is work. Work is work, right? Oh, what? Okay, here we go. So how's everybody's day? How are things with you, Nui? You don't have to say if you don't want to. I hope your day is going well. Mine is not going so well because I expected more drift here. Day was fine, cool. Actually, there's a 10 though. Maybe that's a little bit of a... No, there's a 12. Okay, it's all within the noise. I think I'll just run this all day. If this never drifts, then I'm just all abandon the clock thing and I'll just... Actually, I need to try this on Linux and I need to try it on Mac. Because it could be that Windows is doing something with the performance counter to make it frequency locked, and then I won't see that on Linux or Mac, right? Hey there, Bugfound. How are you doing today? I'm trying to figure out how the performance counter, which I expected its frequency to drift from the wall clock, why it's not drifting. And while I'm waiting for it to collect data, I'm updating my diagnostics so that I can see timestamps, real timestamps instead of these arbitrary timestamps in my diagnostic messages. Condom flusher. That's an interesting name. Hello. Okay, so adding timestamps to my diagnostic messages is what I'm doing right now. So a lot of the tests I'd written before had diagnostic messages in the tests, and I'm adding timestamps to them to bring them up to date. You could try on a Linux system, suspending the system a few times. I could also be trying on Linux. I could boot that guy up. Yeah, maybe I'll do that. Hold on. I'm gonna need to move around, so I'm gonna mute my camera. I just had to reach over and press the on button for the Linux box. I haven't showed that on stream for a while either, so maybe it's a good thing to keep in the habit of it, right? All right, so that goes there. One more place in this file. Yeah, I have 3 boxes. I got, well, I guess they're all 3 boxes. I have a MacBook for Mac, and I have a Linux box and a Windows machine. They're pretty much side by side, but I have to reach over to turn on the Linux machine. Where did I? Ah, right here. Actually, what's going on here? Okay, I actually embedded. I didn't give them names. I just embedded them here. And this is reporting them. And this is seeing that they come back out. Oh, right. I put them in that. I named them that in log messages. Okay. And then here's the timestamp stuff, right? So we will get a timestamp from what? Should I just go ahead and pull in 09K clock? Or no, this has a timekeeper. Where did I put the timekeeper? Here. Let's move the timekeeper up. Uh-oh. Time to clear out my IntelliSense, I think. Let's move the timekeeper up to where I need it first, here. And we'll capture it. And we'll sample the time as soon as we can here. Get current time, and then we'll include that here. And then we'll have to replace the diagnostics publisher to actually see it. Hey there, KHPS official. How's it going? Okay, let me remember which button it is to start up my, I use Cygwin X to connect to my Linux box. Okay, it's booted up. Cygwin terminal, please. And then let me off screen set this up. There we go. It should show momentarily. Sick. I'm sorry. I'm okay. I still have a little bit of remnants of being sick. A lot of people have been getting sick. Spreading, going around the world and all that stuff. I'm still waiting for my, oh, there it is. Okay, so here's a Linux shell. Yay. I can do, let me go to projects, and I haven't done this in a long, long time, so I'll probably end up pulling, oh, I don't have my key. Only really having 2 bad days. Yeah, the last thing that my family got, it was like a fever that lasted a couple days, and then just a lingering cough. Oh, look at that. I was 185 commits behind. I might have to do some fixing. Things that break. I break a thing here and there, and not notice because Windows is forgiving, or Microsoft Visual Studio can be forgiving in its compiler, and Clang is not forgiving at all. Okay, so code. There's my code window. Do I have still the problem I can't move it around? Oh no, I fixed that. That's right. So this is the same Visual Studio code that's just in Linux. So I should be able to build, right? Hopefully it can build. Be really lucky if it just builds without any problems. Okay, there was something. Warning me that, what is it? Temp name is dangerous. It's a warning about exception specification not matching. But it's not an error. And this was warning me that temp name is dangerous. But I'm not even doing that. That's Lua doing that. Don't blame me. I think it's stalling for the same reason it does in Windows. It's running the password strength estimator's dictionary, which takes like a few minutes. I'll let that run in the background. Oh, no, is it done? Done. Oh, there was an error. Find out where that error is. Okay, the go to error button, the F8 doesn't work. Extra qualification on member finish login from the coordinator. Okay, coordinator tests. Actually, it's flagging it for me, isn't it? What's the extra? Oh, right here. Look at that. Clang doesn't like that, but Visual Studio doesn't care. Oh, I have another one. What is it now? Overloaded operator assignment is ambiguous. Yes, okay. I've seen these before. I think I talked about this yesterday. Sometimes Visual Studio has no problem with this. JSON value being assigned to a string. And Clang says, I don't know what you mean. You could mean one of three things. But if I force a cast there, it usually works around it. And there's another instance of it. 332. Same file? No, different file. Same thing here. One of these days I'll figure out how to solve that without needing to do that and without getting an ambiguous problem. Oh, I need to check in the code back here in Windows first, right, to get the latest. Building on Linux, yeah. Building on Linux because I'm not seeing clock drift on Windows. Not seeing any clock drift at all, so it makes me really suspicious. Maybe it's a Windows thing. Oh, I forgot to check in all of that crap. Okay. I don't need to check in this stuff yet. But I do want to check in 09 clock. Okay. I need to make a repository for this. Hold on. Do this off screen because sometimes GitHub shows personal info. I'm just creating a new repository called 09K clock. Public. Created. Okay. So 09K clock git init git add dot, or there's a quick way to do it, right? Commit am initial revision. Nothing added. Obviously I didn't know how to do that command correctly, but now it works. Git remote add origin git at github.com, my name, 09clock.git, git push origin master. And then mugget add 09k clock. And then I can check the get ignore add and the manifest add. They add 09k clock. And now I can push there and go to Linux and pull. I have changes. What are my changes? Oh, yeah. Fix things, right? There's Get GUI on Linux. It looks slightly different because my font sizes are smaller. I won't bother changing it right now. You'll have to excuse my small font for a moment. So this is fix compiler errors in Linux. I think you can look at the diff and it's self-evident. Commit. Why do I have... Oh, I think I was playing around with running things from a different directory there. That's why. Git push those, and now I can... Oh, rejected. Okay, let's rebase. Why is it having me do that? Fetch, that's right, because I didn't want to do pull, I want to do a fetch. Git commit -a only adds modified. So yeah, what's the untracked one? So it's not -a. Okay, git rebase origin master, right? And then push. And then I can pull the, this'll pull the 09k clock in, and I can build everything again. Cloned. So I can build now. Oh, there's something missing. Oh, did I have it capitalized? Linux cares about case. Windows doesn't. What do I want to call it? I think I just want to call it lowercase Bob. There we go. Oh, it's not this folder. It's 09k clock. Fix a case of bob.cv in CMake lists. Okay, now we can run Bob on Linux and see what's different. It's a 09k Bob. Capital Bob. Interesting. Still have sub microsecond accuracy, but it actually implies that there's more precision. Interesting how that's walking up. Okay, it reset. I think that's because I'm only having it sleep an integer number of milliseconds, so it's slightly creeping up in the microseconds, and then we catch up. Anyway, I want to see that. I was hoping to see this drift, and it's not drifting at all. Oh well. Maybe the high precision. Okay, maybe my assumption is wrong. I was assuming that. Let me show you guys the. This facility I'm using. Query performance counter. I was assuming this performance counter was not frequency locked to the system time, to the system clock. But apparently it looks like it is. Or I'm having horrible luck. Because I'm not seeing any drift at all. Like I expected. Absolutely no drift. You lost count of the number of times you've used case-sensitive Linux and gotten shut out? Yeah. It hardly ever happens to me, to tell you the truth. So this is sort of unusual. I swear, it doesn't happen all the time. Okay, yeah. Let's make a new terminal. Let that run for a while. I didn't change anything, did I? No, I just have some untracked files. Maybe I'll just let that run and I'll continue working. I was really hoping to see some drift. I need to see drift because then I'll know the frequencies differ and then I can write the code to adjust for that. Maybe I don't need to write any code. Maybe this is just proving to me that I can just use system. I can use the performance counter and it's frequency locked to the system clock. Either that or it's drifting so slowly I'd have to let this run for a long time to see it. What does NTP say my drift is? We are locked to what? This random NTP server. And the... Which one is drift again? I think it's... Oh no, this doesn't show drift. This just shows us our offset. I think it's in milliseconds? No, that's our delay in milliseconds to the clock, and this is delay in our offset between our clock and the atomic clock in milliseconds, right? If I remember right. And then jitter is how much that either the offset or the delay is shifting around in time. There was like a drift file, right? I forget how to do this. Is it for the daemon? Yes, there's a drift file. Default is etc ntp drift. There is no drift file. I don't know where it's being stored. Maybe I won't look into it that much. No, NTP, Network Time Protocol. No drift. I should run that with a T, though. I'll call Bob Linux. So I can copy the file later. Maybe I'll just use system clock. All I really need to do is try this on Mac and make sure if system clock has that good of a precision, I don't need the performance counter at all. I don't need to do this funky frequency shifting crap. Anyway, back to what I was doing before. The main program here gets the current time, and it's reporting it, but we're not publishing it. So let me make a different kind of publisher. Custom publisher. So what are we going to call it? Make diagnostic publisher. Publisher. I can put it anywhere I want. Let's put it here. It's this. This one. Okay. Very long type name. And by default, it does this. Create and return an object of a delegate that will publish diagnostic messages to the console. And there's no argument. There's a return though. Okie doke. Build it. Build it and I'll just rerun the cluster and make sure it still works. So now there should be extra stuff for me to see. Actually, let me check. I don't remember if this is being forwarded or not. Wrong shell. Look at it in network. Where do we see the diagnostic messages? Oh, here, this batch here. Oh, they're timestamps. Look at that. So, oops. Sure, this is more room, please. So there are now timestamps being included in the messages. That's good. Now I need, do I want to print them there? Print them there and then also show them in the orchestrator instead of that. So the orchestrator should be getting them too now. Orchestrator. It runs as a service. Here's the service. Where's the diagnostic stuff? Right here. So it's got its own reporter. And it's doing the same thing, so I guess I want to do the same kind of thing that I'm just going to do here. Have a make diagnostic publisher. Just copy it as is for now. What am I developing? In the large scope, I'm making a game, but from day to day, I'm working on pieces of the whole system. The system is very large, but when this all comes together, it's going to be a multiplayer RPG with 2D pixel art. I can show you a mock-up, a little experiment prototype I had made. That is, I need to run build iron glove backend, iron glove, and then that's the back end, and the front end we can run here. I think it's on this port number. No? Error. npm didn't start correctly. Front end of my game is going to be in JavaScript using either Pixie.js or Phaser. Hold on. Wait a moment. Just wait a moment. Usually that starts up pretty quick, but maybe not. Hold on. I'll get back to showing the demo in a second. While that's running, let me, I was going to copy paste this over to this program here. Where do I want to put it? Put it here, for lack of a better place. The back end is in C++, the front end is JavaScript. So yeah, today I'm working on bits and pieces of the back end. Okay, there we go. This is actually showing both Pixie.js and Phaser. Let me check out the Pixie only branch. And I have too many shells. Check out master. All right, and then this should reload. Okay, so here's a mock-up of the art style. I mean, I drew the art really quickly in like a few minutes, so it's really horrible. So I hope to get better art than this, but this kind of gives you a very, very extremely rough idea of visually what the viewport of my game will look like. I'm just starting. I can't make like World of Warcraft or something like that by myself. It's impossible for one developer. So I'm trying to shoot for something a lot more approachable, which would be to begin with a very simple game, just making it multiplayer and have the art be simple enough that a non-artist like me could actually draw it. So simple avatars for the hero or for monsters, and for the environment, and then get something up and running and then see what I can do from there. So very, very primitive 2D, well, I guess you call it cell tile-based graphics and art. And I should have shown this while I was playing the game. It is split between a front end and the back end, so there's a WebSocket between, so all updates to the display and then any any input that you do. Like here, you can see those green messages, or when I'm changing movement keys, or if I'm firing. Fire, fire, fire. Those are all through messages over a WebSocket. So like here's an update telling me that that the axe that I threw has been moved to a certain position on the screen, right? And here's a message going the other direction saying I'm no longer holding down the fire key, or here I was holding down the A key, which is left for the fire key. So bi-directional communication between front end and back end. The back end runs the game, and the front end is just showing the game and then taking any input and giving it back to the back end. So that's roughly what I'm trying to construct, but in a much larger scale with multiplayer and all that. This mock-up took about a week, and that's actually in my GitHub if you want to play around with it. Just look for Iron Glove backend and Iron Dash Glove for the front end. So I do expect to see some lag. So one sort of cheat that I'm doing is you only move whole tiles, and you can see the movement rate is pretty slow. It's the game is running at 10 FPS, and I'm not allowing the hero to move every tick, but I think every other tick. So that gives me 200 milliseconds of lag resiliency, right, so to speak. 10 FPS, you have 100 milliseconds to do whatever the hell you want. As long as you're done in 100 milliseconds, you won't notice any lag above the fact that you're running at 10 FPS. So that's why I'm keeping the frame rate low on purpose to be able to absorb more lag. If I were to run it at 60 FPS, my budget would be a lot tighter, and I would have to do a lot more optimization and stuff. So to begin with making the game, you don't want to set the bar too high. Set the bar pretty low. If you can meet the bar, then you start doing things like increasing the frame rate, increasing the speed of how things of the game in general, and that's a good problem to have. That you have the game slow, but it still works. I don't want the opposite problem. I don't want to be trying to get 60 FPS and then never making it because there's too much lag. That would be a bad problem. Oh, you're suggesting write the front end in C++ but compile it to WebAssembly? Yeah, that was mentioned. And why not would be because it's more work. The front end stuff I'm doing so far, it's much quicker and easier to do it in JavaScript than in C++. And why am I doing the web browser in the first place is mostly portability, so that I don't have to worry about porting the graphics stuff from, to whatever platform you might want to run it on. Mobile, Mac, Linux, Windows, whatever. It should run as long as you have a browser that can run the either Pixie.js or Phaser, and those are pretty well ported onto every single platform there is, right? So yeah. And I've been tracking these, and I'm hoping to see drift. I'm just not seeing it. Oh well. Anyway, what I'm working on immediately right now is turning. I want to see the timestamps of all my diagnostic messages not be relative to when I start the program, but relative to the Unix epoch, right? Actually, be real timestamps that I can convert into a date and time and all that. Electron for desktop, I could do that, but right now I'm just keeping it simple, and it's just it's a React app, so it's you have to download it from the server once, and then you have it. So yeah, I want to get a working game first, and then things like building it on top of Electron or Cordova would be like polish or optimization, right? Okay, so make a publisher. I need to actually use it. So that's an impl, right? Actually, this should be moved. What is that? The impl class itself? I think it might be. Wow, I got a lot of. This file is huge. Okay, there's the impl. Here, this is the anonymous namespace I can put stuff in. Been a while since I worked on this specific component of the game called the orchestrator. Orchestrator state. So let's put it here. Then in this impl, in its do I have a constructor? I don't have a constructor, do I? Okay, but maybe this is where we can do it. We can say that equals that. Oh, wait a minute. I'm doing it down here. What am I? What was the point of this? Oh, this is if we log to a file. If it's running as a daemon, we're logging to a file instead. So I see what I'm doing. So what do I do? Oh, there isn't the original one. Okay, so let me forward on the file handles here. So standard out, standard error. And we'll have this one take those as arguments. Normal output file. These are files, right? Error output file. Am I dropping frames? Nope, I'm not dropping any frames. Sorry, bug found. Mine says drop frame 0. That's too long. Let's wrap it. I hate it when I misclick and like the whole scroll position changes. Very disturbing. Okay, there's the normal input file. I can't spell worth crap today. This is the file to which to write normal, not warning or error messages. To write warning or error messages. There we go. So then I have that factory is called from 2 places. By default, we'd write to the console, but if we're running as a daemon, we're going to write to a log file instead. But either way, now I have one place where we can make adjustments, and that's what I'm going to do. You can view personal frame drops framed under settings, advanced views, video stats. Oh, it could be Twitch's end. You want me to look? Wait a minute. Are you saying that settings, advanced video stats are on the viewers, not for me, right? Does Twitch actually record somewhere on my dashboard, perhaps? Oh, there you go. There's a stream health. It says excellent. View details in Twitch Inspector. Oh, I have to log into the thing? Yeah, I see a consistent 2 megabit per second with no drops on my end. On both Twitch and on OBS. I had 2 days in the past couple of weeks where I did have to reset my modem, and it was pretty obvious. OBS was telling me I was dropping tons and tons of frames. And I just reset my modem and continued on. Let's see. Yes, so we're going to take this default delegate and make our own version of it, which uses our own clock. Actually, that means I'm going to want to pass in our timekeeper, right? Do I have a timekeeper? It's probably here. Here it is. So it's part of the shared state of the orchestrator. So we can pass it in. Shared pointer to timekeeper. No suggestions. This is the object used to track time in the web server. Well, in the orchestrator. In this is used to track time. Track real time. And when I call it, I give it access to impl shared timekeeper in both places. Okay, so we have access to our own timekeeper, and so I don't need this at all. Why do I have a mutex? I don't think I need a mutex. I think it's already going to be serialized, right? Well, no, we can put it in there. We can keep it in there just in case. Time reference I don't need. What is this output used for? Oh, destination. So this is normal output file. And this is normal error file. Or this is error output file. These three places. Don't need time or reference. I do need the time keeper though. Let's put it in the right order. There we go. Okay. And prefix that with the namespace. Okay, so here we're going to actually just ask the timekeeper for the time. Oh, wait a minute. No, this is not what I want. Right? I want to use the original timestamps. How is this gonna work? Oh, maybe what I'll do is I'll just include it in the messages themselves, right? That makes sense? Let me think about this. Yeah, then I can see both when the orchestrator is printing it and then when it was when it originated. What is it called? Get current time, okay. So this should show me, I need to stop the orchestrator. This will show me when the messages, oh, it didn't work. I'm running the wrong thing. Okay, now we have real timestamps of when the orchestrator is printing it, or when the orchestrator captured the message, really, right? No, when it was published. This is the published time in the orchestrator. So I kind of want to also include with this guy the time it was captured in. It's going to take up a lot of real estate, though. Your speed is fine? Yeah. Blame Twitch. Sure, we can blame Twitch. Interesting, I'm seeing these token value. I wonder why. I don't remember what I was... This is replaying log entries from yesterday, and I don't remember what I was testing. Okay, so we got that part of the timestamp done. Now for this part. You're losing much, but you know it's your computer? I'm sorry. I hope you get a better computer. All right, so there is a place in the orchestrator where we receive messages, right? Diagnostic messages. Right here. Okay, so here I can formulate the message. So that's sender, and that's the rest of the message, I think. So what if we just put it in front? Wait a minute. Why am I doing string? Why don't I just do... Oh, because this was more efficient. But now I really do want a formatted message. LF. Actually, I will do... Let me think about this. Yeah, I'll just be lazy. Let's be lazy. Timestamp. Sender. Message. And those need to have a C string at the end. Hey there, Romania Hate. How's it going? I'm okay. I'm working on improving some diagnostic messages in my game. Why is this flagged here? Preceding parentheses, if a parent call must have pointer to whatever that means. Is that because I have no comma? Yep. Okay, and there's more stuff here. Need to do the same thing. That's if we receive them as part of a batch. So that's what those less and less than meant. Although I probably won't need those anymore once I do the sorting of the messages by time. Can't build it while it's running. There we go. Now we're seeing timestamps. If it's originating from a Realm server, we're seeing that when the message was generated and then when we published it. So there's a 2-second gap because of the connection. We're connecting and then we're getting a batch of messages that were generated before we connected. And then these should be near real time, so they're lagging by 400 milliseconds. There's a lot of lag because it's a debug build. Actually, no, it's not a debug build. It's a release build. Why is there so much lag? Actually, it might just be the time it takes to print to the console. If I do this and then output to log instead, and then I look at that log file, I bet it'll be a little bit better. No, it's still a 300 millisecond lag. Oh, I wonder if it's because the clock, yeah, the timekeeper I'm using, the offset in the fractional number of seconds is arbitrary. Yeah. So I need to, if I move to system clock, these should be come back into alignment. But you can see here it's not taking much time at all between messages to print them, whereas when I was going to the console, it was, right? Like 10 milliseconds, and here it's less than a millisecond. There's a penalty of like 10 milliseconds to print to the console in Windows for some reason. Go to a file though, it's immediate. These messages were generated within 10 microseconds of each other, but it took 400 microseconds to transmit them, I guess, and then publish them. Yeah, because each of these is a JSON message, so it's about 400 microseconds to generate JSON, transmit it, receive it, parse it back, and then print it out. Don't have the cycles to spare to watch today. Okay. Hi and bye, Clavinex. Thanks for coming by. Yeah, the Windows console is be slow. There's always some overhead. So yeah, the overhead is reduced if we pipe to a file, where our overhead is now about 300 to 400 microseconds, which is not bad. And if I offload that to another thread, that makes it even better in terms of not slowing anything else down. And so the cost, there's sort of a high cost in that. The useful part of the message is less than half the screen now. I think I'm okay with that because realistically, the way I'm going to look at this is like that. I'll be scrolling to the right and looking at the messages. And if I care about the timestamps, I'll scroll back to the left and see them. In fact, I wonder if I could change the order of this to fix that. I'd have to build that in as part of the sender string. That won't work. Keep it the way it is. Where? I have too many windows open. My Trello. I forgot to update this stuff. Oops. Whoops. Lots of misclicking going on. This is all the stuff I did last stream. We're going to archive all those cards. And I was working on that and this time. Same time, right? This we're doing now. I mean, we're done with. This I'm still tracking in the background. And the unexpected conclusion I'm reaching is that the performance counter is actually locked to the system clock, which I didn't expect. Makes me think I should just be using system clock and not this, and abandon this 09 clock. Much faster to boot with printing disabled, yeah. It's not the formatting either. I'm still formatting these messages with, I think it's VSPrintf. So the formatting itself perhaps is the 3 to 400 microseconds. For some reason, it's going to this dang console that like takes 10 milliseconds. What's that? More than an order of magnitude longer to go to this console than to go to a file. It's really weird. And I don't know if it's the console or the console wrapper that I have, which is ConEMU that I'm using. Who knows? Maybe I'll do this one next. Offloading the diagnostic log reporting to another thread because it can take a long time to go to the console. Let's do that next. And this one we're doing in the background. Just right to the file and watch the file on the console. That's what I'm going to be doing most of the time anyway, but while I'm debugging, I'm doing it in the console, and I don't want me debugging tripping things up, right? Causing artificial delay to the system. So it's more for my own convenience while debugging. In the real system, this will be going to a file. All right, so let's see. It's actually not that bad. What I can do is, now that I have this cordoned off under make diagnostic publisher, instead of having it directly write to the file, we can put this into a structure that we queue and then have a worker thread later pull it off and print it. Yeah, I like that idea. So I can also simplify this a bit. I can move this into the orchestrator proper, into this shared state. Make that a function here. Indent it, and then I don't have to pass in the timekeeper because it's actually a member of that same structure. Except for that. Oh, it needs access to itself. Right, so does this structure inherit from shared from this? It doesn't. Well, we can make it so. Public. Shared from, enable shared from this. I don't need to do that. Right? No, I need to, it's a template with our own type as an argument. There's a little trick what you can do. If you know that this is always accessed through a shared pointer, you can do that. Why is it not like it now? I think that's stale. If I rebuild, it'll go away, right? Nope. What am I doing wrong? Oh no, it's not that. It's later compiler errors. Yeah, so that's a little trick so that I can do this down here. Standard weak pointer to my own type. Self weak is constructed from shared from this. So it takes this and makes it, it recovers, it adds a reference. It only works if the object, this object is accessed always through a shared pointer, which it is. So I can make that weak pointer, pass it in here, and then recover it. The reason I don't do a strong reference is because I'll end up making a circular reference. So I'll never be able to destroy that object because that object made delegates which have strong references back to itself. So this is sort of a pattern I've come to follow, that when I make these delegates or callbacks or functions that we pass off to other things, that we don't hold strong references back to ourself. That helps us avoid circular references. So what I do is const auto self weak.lock, and in the event that it's already been destroyed, we just return. And it doesn't like timekeeper because that's now self timekeeper. And then when we use it down here, it is impl shared make publisher. Oh, and I don't pass in the timekeeper anymore. And can't compile it while I'm running it. Now it built successfully. And it didn't break. Still good. Okay. Now to modify this. Right, in addition to... Not in addition to. Instead of printing it directly, we're going to queue something to do the printing for us. And since this has got overhead in itself, we'll queue this entire thing, actually. This is going to look ugly, but what I kind of want to do is take that entire thing and wrap it in itself and push it onto a queue. Something like this. After we recover self, and after we grab our own lock, actually that's not our, we don't need our own lock. Oh no, that's just a serialized access in. Yeah, okay, so after that, self, queue, diagnostic message. Actually, we can just make it more generic. Queue asynchronous. Queue delegate. Queue worker delegate. And then make this entire thing an inner delegate. Does this ask? Actually, what we do is we capture the time, right? That we received it. I might not actually need to print that anymore. Actually, no, I still do, because some messages come directly from the orchestrator like that, and they have no other timestamp. So I still need that. Yeah, we're going to collect that before we do this. Const auto now equals, and then we'll capture now and the other things that we wanted. Normal output file, error output file. We do not need the, no, we do need the mutex. But that's it, right? Oh no, also capture the sender name, level, and message. And then we do this stuff in that. And that is now. So this is saying do all the work later by putting this function on a queue that we're going to call. And it doesn't even need self, right? It's just printing to those files. Actually, let me make sure that those files are shared, right? No, they're not shared. We should make them shared. Thanks for the follow, Lem314. Yeah, that would make more sense. We don't want them closed while they're being used, so shared pointer. Actually, there's a trick I was using, right? It was unique pointer. Oh, so we need to make it shared. Yeah, I was using unique pointer with a special deleter that calls fclose when we're done, but let's make it a shared pointer. Because then I don't need that. Right? And then let's make this not call get, but actually share it directly. Which means I need to wrap those with the shared pointer, which we can do. We just do a null deleter. Like that. We don't need to ever close standard output or standard error. And then just make this one take shared pointers. That way the log file stays open as long as we have an outstanding delegate to that is trying to print something. And then destination needs to be, well, this can be a get. That'll work. So now I just need to make that a function. I need to make that a thing we can do. Let's put it here. So void q something. So function that doesn't return anything, and we don't need to give it any arguments. So we call it a worker delegate. So simply put, I don't have a lockless data structure right now, so but I do have a mutex, right? For the main object. Do I? Thought I did. Maybe I don't. Oh, I do. So get a lock guard, and then we're going to have some kind of worker delegate queue. So we're going to push onto it the worker delegate, and then we're going to need to wake up the worker. So that would be something like why am I writing this from scratch where I could just copy from here? I have a worker here, don't I? No. Where did I put a worker? Was that in coordinator? Coordinator impl? I think I had a worker here. Yeah. Oh, this is a polling one. I don't want this kind of a thing. I'll just do it from scratch here. Wake worker notify 1. So I need to have both the worker delegate queue and the wake worker, which is a condition variable. And we're going to want, while I'm here, I'll already have thread. I have a thread? Oh, I already have a worker. Interesting. So what is that worker doing? Hold on. Hey there, the Epic Unknown. How's it going? I'm making the diagnostic reporting in my orchestrator asynchronous so that because of the performance hit actually formatting and printing these messages takes, I'm offloading it to a worker thread right now. And is this the worker thread? So right now all it does is waits for this shutdown flag. And it's got an arbitrary 10 hertz polling loop. Okay, I know how to fix this. So this stop worker, we'll put a condition variable next to it. Wake worker. How'd the clock measurements turn out? Kind of unexpectedly. So it didn't show any difference, and then all of a sudden, after a couple hours, it jumped to 3 seconds difference. And I think that was my system clock adjusting to the network time. And then it stayed at that. I actually expected it to adjust 1 second at a time and keep going. So this is sort of inconclusive. I don't know why it jumped. I can only speculate that it's because my computer's clock decided it was 3 seconds off from the internet and just said, okay, I'm going to adjust. So what I decided to do today was I am using now system clock in C++ rather than time. So I'm using system clock now, and actually it turns out that it has pretty good precision. And disappointingly, though, I'm seeing that I'm not getting any drift at all. So this has been running more than an hour now, and it's not drifting at all in frequency from the performance counter, which I didn't expect. I thought the performance counter would be not locked at all to the system clock, but it turns out it is. I don't know why. Either that or I'm going crazy, and I implemented this clock here incorrectly. But this is getting the time directly from the performance counter, and just basing that off of an initial wall clock sampling. So this, I thought that this frequency would not be locked at all to system clock, but it's not drifting. And I tried even on Linux. I have this running on Linux as well, and it's not drifting at all. So I'm kind of baffled why that is. I might just give up and just use system clock for my clock. Why not, right? It has the precision. It seems to be the same as far as frequency to what I'm already using. And it's supposed to be locked to the internet, so might as well use that. I don't know, man. I even think if I looked at the documentation of this again, it warned about it not being locked to system time, but it certainly looks like it is. Yeah, why not? Like, yeah, well, I can do it until I see a problem, right? Okay, here, so we're making this reporting of messages asynchronous. This is signaled whenever the worker thread, the orchestrator, should wake up to either exit or perform some work. So we'll modify the existing mechanism here. Instead of waiting for the worker told to stop, we'll say, actually, we need to grab the mutex, right? System standard unique lock decal type. Is it impl? Shared mutex? Lock, and then the same thing. I call my unique locks lock. I could call them Bob, but I prefer to call them lock. What is it not like about that? Non-static member? Is that really an error, or is it just... It really is an error. Impl undeclared identifier. Oh, I'm already in impl. Okay, so I don't need the impl stuff. There we go. That should fix that part. All right. So if shared wake where did I put wake worker? Which class is this? Is that the wrong class? Oh, it's the wrong class. What the heck? It needs to go into the shared properties. Right here. Dot wait Actually, here we could, so I'm going to replace that hard-coded wait with a wait for here. So this, a condition variable needs a lock first, then a period. So that's this. And then a predicate, which we will make shared. Return, so we'll return either two things happen. Either this one returns, so wait, hold on, I guess I have to use this. Wait, okay. Break, right? Worker told to stop dot wait. How come it's not helping me out here? Dot. Okay, we'll just type it in. Wait for, and then we need a placeholder. So standard chrono second 0. I just want it to poll. So basically, if we've been told to stop, if the promise has been set, then we will. If it doesn't like it. Cannot be implicitly captured. Why not? Oh, shoot. It's the future from that promise, right? Okay, that's one condition, but I'm going to add a new condition in a second because we have this queue that we're going to be pushing onto. Wake worker. So let's declare that queue. It's a function that doesn't return anything, doesn't take anything, right? Can't you use a bool stop signal and signal the wake worker? Yeah, I guess I don't really need a promise anymore now that I'm using a condition variable. I'm obsoleting the promise by doing this more generically, right? Q is not declared. EQ. It's functional also? No, it's there. Why isn't it not like that? IntelliSense, yeah, IntelliSense is just giving me a hard time. All right, it's okay. This holds functions or delegates. Delegates? I like delegates. Delegate is like a refined name for a function object. Holds delegates to be called by the worker thread. Okay, so we push, and then when we're waiting here, we need to rename this. This is worker. This method runs as a worker thread, performing any asynchronous operations needed, and polling the shutdown flag until originally that's what we did. We polled the shutdown flag. Maybe that's what that's what I'll do instead, having this promise now. Yes. But the only thing I do is I set it there. What did interrupt handler do though? It set shutdown as true. Oh, right, because return waits until that happens, right? I mean, our run waits until it happens. What is this service told to stop service? Stop. When is stop called? On shut, like many different paths I can take. Okay, ultimately that sig int goes to shut down. Right, because we could be told to shut down, right? There's many different ways we can be shut down. If you hit Control C, it sets that flag. If you are told to shut down, instead of setting the flag, it calls stop, which sets the promise. So yeah. That shutdown flag, it must set a promise also. Oh, here it is. Wait. Oh, this tells it to stop. Oh, there are two ways to leave the loop. If you hit Control C or if you are told to stop. That's confusing. Why did I do that? I don't remember why. Shouldn't it just call it down here? I'll have to I'll have to review this code later and figure out. I probably have some tangled logic I need to clean up. But for now, I was going to try to see if I can get rid of this this promise here. By just reusing that same flag. Use the tell to stop early before the shutdown flag is set. Yeah, why not we just use the... Yeah, why not? Just use the shutdown flag. I don't need to capture this junk. Shutdown flag is global. Really, there's no need to have it in both places, right? This could be an infinite loop. And then shutdown is true. Oh, but then we also need to notify the wake worker. And we should do this while holding the mutex. To avoid that race, right? So... that can be a lock guard. That needs to go in front of there and there. I don't need that. Okay. So while holding the mutex, set the flag and notify. Oh, wait a minute. Is that why I had... maybe that's why I had the promise, because we shouldn't be grabbing any mutexes or stuff in there. Oh, wait a minute. I'm polling anyway. I don't need to do any of that. What am I thinking? It just causes a delay of one loop, of one polling period. Okay. Yes. This should work, right? Let me test to make sure I didn't break anything. Uh-oh. Never ran. Okay. Build orchestrator localhost. It's just crashing. Okay, what did I do wrong? I don't know. Let me, it's in release build. If I switch to debug build, it'll take 5 minutes. So let me see what I can do with this. Debug of the release build. What could go wrong, right? Exception. Yeah, I'm gonna have to at least do a release with debug info. This should not take 5 minutes. This should only take like 30 seconds. I think I am initializing it to false. Yep. while I'm letting that build, let me see how my clocks are doing. Still saying that they're not drifting. And Linux is a lot more precise than Windows, apparently. Doesn't surprise me. Linux is a lot better than Windows at time stuff. I could make this lock a lot better by doing microsecond level counting of amount of time to wait. Wait a minute, couldn't build something? Oh, we're running Bob. We can't build Bob. Well, build everything else, right? I'm gonna stop trying to build whenever it tries to link Bob. Every time I run, it'll build a little bit more. Build everything but Bob. I guess I could take Bob out of the mix for a minute. Yeah, I'll just do that. That's easier. So, remove Bob. Check the return value from wait for. It's not a bool. I thought it was. Just a second. Where was I? Oh, 9K clock, right? Remove Bob for a minute. That's how you comment out things in CMake, right? Yeah. All right. Wait for condition variable returns a bool. You might have been thinking future wait for. So yeah, I'm switching to using a condition variable for the outer one, and that is returning a bool. If you use a predicate, which I am. So yeah, I ditched the promise future thing, and I'm using wait for with a predicate, so it'll return a bool. And it returns a bool if this predicate return. It's basically returning what that predicate returned, right? Equivalent to return wait until, which does what? But the predicate is equivalent to returning the predicate, or returning the true if the predicate initially returned true. I think we're good. Oh, I think I grabbed the lock twice. That's the problem. Yep. Grab the lock, and then Q is also grabbing the lock. So Q does not need to grab a lock. Yeah, it's not a recursive mutex, so it's going to have a problem locking twice. That's what it was. Okay, so they're all queued, but it's running now. Let me make sure. It's not actually processing the queue yet, but it should be running. I should see that here. Yeah, so it's running, just not printing them out, not dequeuing them. That's okay, bug found. It's good for me to check in anyway, right? No matter who's right or wrong, doesn't matter. Good to check to refresh my knowledge. Make sure I understand what I'm doing. Okay, notify, right. So it's gonna be in the queue. So now we're gonna wake up for two different reasons, right? So either shutdown or the, what is it called again? I was just looking at it too. Worker, some kind of queue. It's in shared. Worker delegate queue, not empty, right? And then I guess it makes sense to, right here, process the queue. And we kind of want to do it in a smart way. We'll do it this way. No, wait a minute. What am I doing? Do it after the if, right? hold on. This will wake us up, but we'll only want to break if it, see, I'm going to move this back. So instead of breaking, it's going to do while not shut down. There. So we'll wake up. And actually, I don't care about the wait for what it returns, right? Whatever reason we're going to wake up, then we'll process the queue, and if shutdown was true, then we break, then we fall out. So while, here's the smart thing to do. Process worker delegate queue and give it our lock. Then I can add more lines here that also do stuff, and then just assume that everything here is protected by that lock still. So this is a unique lock. Actually, can I do... I can't do that, can I? I have to make sure... I have to use that type again. What's the version of Visual Studio? 2017 community. I don't think I'm running the very, very latest, but I'm running a few patches back from the latest. Why would you have the queue empty check in the predicate? That's to wake up. So the wake up can happen spuriously. So the predicate you give is to tell it whether or not it should actually continue waiting or not. It's true. If you say, if this returns true, it should stop waiting. False, it continues to wait, right? So these are basically the two conditions that we say we want to wake up from, or return from this wait for. So if we're told to shut down, or if there's something in our queue to process, and then I process it, and then if it was shut down, then we fall out at the end there. That's the reason. So the smart thing to do here, I think, would be to have another queue. Decal type shared that delegates copy. And then clear it. Actually, no, what I want to do is do a move. Or I want to do a swap. Delegates copy swap. Swap with that. So that swaps an empty queue with the current queue, and then I can release the lock. And we're going to lock it again when we leave, but in the meantime, we're going to say for const auto delegate to call and delegates copy. Call them, right? There we go. Well, wasn't the purpose not to delay the queuing? It won't delay, right? It will, because when we push into the queue, we also notify the condition variable, so it'll wake up immediately. I would like to do that in the interrupt handler as well, but what I read is you're not supposed to do much in a signal handler. So it'll incur a 100 millisecond penalty. We have this one. Where did it go? This one, that should wake it up right away. And identifier not found. Did I misspell it? Oh, you can't do that with a queue. Okay, fine. While not delegates copy empty. What is it? Const auto delegate to call equals delegates copy top or front, right? Call it and then pop it. There we go. So now they're printing out. And it's being done in a worker thread now. So it should not incur the penalty. And yeah, you can see it's the same performance I was seeing when writing it to a file. Only there's going to be a little bit of a delay in actually seeing it, which is fine. You don't understand what I'm doing? Oh, I'm sorry. Let me try to explain again from the start. So make publisher. So whenever a diagnostic message comes in, we're going to queue another function to be called, right? And when that function eventually gets called, that's where we format and print out the statement. But in the meantime, we're taking that function and bundling it into this queue, standard queue of functions, and then we notify this condition variable, right? That condition variable is used by the worker thread as we're waiting for some condition to be true. So notify one always wakes it up and rechecks the predicate, right? So the only times I'm doing notify right now are when we queue the delegate to be called, and I think I called it at the end, right? I guess I could. I'm not, but I could call it. I could do it here. I guess I decided it didn't matter. So really, the only times it'll wake up. I lost my place. The only times it'll wake up is if this times out, 100 milliseconds, or a spurious wake up, or it was woken up by that notify. Any of those three conditions happen, it rechecks the predicate, and if it returns true, we return from wait for. Process that queue, and then check the shutdown flag, and then continue or not, right? So the three ways it could wake up. Spurious. It wakes up, and this is still false, so that just goes back to sleep. Second one is where it times out. It times out, it'll see that it probably has nothing to process, but then but it'll still poll. It's basically polling the shutdown flag. Third way is where we notify to wake up because we put something in the queue. So it'll wake up, it'll actually process that queue, and then loop back. It's not shutting down yet. It goes back to sleep again. So in all three cases are, I think, handled as well as I can. I can remove this polling and make it a wait without a wait for if I was comfortable in this interrupt handler to do the notify once, but I just don't know if that's safe. I could try it out right now. So that would be actually then this interrupt handler would have to have access to that. A little bit more complicated. I would have to make a global variable for that condition variable. So like wake worker would have to be static, and this whole thing has to be a public structure. I think it is. Yeah, so wake worker, if it's static, then in the interrupt handler, I could notify it. As long as yeah, so it's already a singleton anyway, right? By nature of I only make one of it. So this should be safe. And then I can remove the 100 millisecond polling and make that a wait, right? Then there's only two ways it can wake up. Either we told it to wake up or it's a spurious wake up and it goes back to sleep. I just don't know if it's safe to notify, what's this? Unresolved. Oh, right. When you do one of these, you have to give it storage. So after the structure declaration, gosh, it's a long structure. Way at the bottom, actually right here, we give it storage. You have to repeat the type and you say the name of the class. Help me out here, IntelliSense. That one. Give it storage, right? So now when I hit Control C, it immediately terminates. I just don't know if that's safe to do on every OS. Actually, did that terminate correctly? No, it's not even terminating correctly. It's like uncleanly terminating. Maybe it's crashing. Let me see. So run an debugger. Get the window here. Hit Control C. Where do we end up? What's the wake up for? I think it's what was here when we hit Control C. What it's telling me. So we'll hit that, right? If I hit go. Okay, yeah, we hit that and then continue. Did it not shut down correctly? Something tells me it's not shutting down correctly. Let me try this again. Control C, and then go, and we hit the interrupt handler. Okay, it is going through this. Oh, but it's the all the diagnostic messages are queued. Right, so we're just not seeing them. I can fix that actually. That I can fix if we do a final processing at the end. Right? Actually, there are two paths here. I think what I want to do is at the end of run. Let me think about this. You find it difficult to debug Control C shutdown? Hey there, Mr. Muffles. I was looking at chat right when you sent the message. Oh yeah, Control C shutdown. It ends up being a type of an exception, right? And this one has it breaking on all exceptions. You might have to play with that. There's an equivalent thing in Visual Studio to break on any kind of exception, and Control C is a kind of exception. That join is probably what it is, because what is this? It calls after main returns. Let me think about this. We're not running as a daemon. So at the end of run, we called shutdown. So it should have queued some extra messages. That'll queue messages, and it should have printed that, which gets queued. And then we tell the worker thread to shut down. Maybe I don't have a final. No, I had a final processing of it, didn't I? Anyway, this should have also done the. Oh, doesn't matter. Yeah, this does a final processing of it. Oh, but no, hold on. Stop. Ah, yeah, we need to do one more processing. How do I do this? Oh, this should be moved up here, and then we can do this one last time. That should fix it. No, it's not printing it. Why not? Let's try again. Debug. You got food poisoning? Oh, shucks. Sorry to hear that, Mr. Muffles. Yeah, yikes. I hope you get better soon. Okay, there's the exception, and then I go, there's the interrupt. Then we're shutting down. And then here I should be able to peek in and see those messages queued up, actually. No, it's empty. But it didn't print them all. Didn't print them all. What happened? Weird. All right, let's try that again. Go here. Oh, wait, hold on. Right. Oh, okay. We processed it too early. So where is this actually called from? Shut down? Part of run? Oh, the worker thread is ending early. Oh, right, because, yeah, okay, got it. So it doesn't matter if we call it here or not. What we really need to do is call it only in this path. I guess right here. Do I have a mutex held here? No, I don't. Okay, just really quickly. I need to make a lock. Here. And put impl in front. There and there. Oh, and that has to be impl shared, I think. Right? Not shared? One final processing of the delegates right before we exit. There we go. So, yeah. This is safe to do in our interrupt handler on Windows, at least. I just don't... I guess I was trying to play it safe and assuming that we can't do something like that from a signal handler on every OS. So to play it safe, we can go back to not doing that. And then it will just incur a 100 millisecond penalty between when I hit Control C and when it actually polls it and wakes up. Actually, right now it won't work at all. Oh no, it does work. Did I, oh, it worked because it was printing something at the time. But just to be sure, we do a wait for, and then we put back in the chrono. So it at least polls the shutdown flag once every 100 milliseconds. So if it's not printing anything, there'll be a delay of a tenth of a second before it actually terminates. Wait until it's not printing, and then hit, yeah, it's barely noticeable. Does anyone else have access to clear the queue? No, but if they did, they be the convention I have in the code is that you have to grab the mutex to do it. Yeah, but this, by design, this is the only thing that's going to empty it and call it, is this process. All right, we're done with this for now, right? Check that in. Condition variable queue. We're sharing the state with that work with those delegates. The files now are shared too. So we've offloaded the printing out of messages to a worker thread using a queue. Oh, I don't want that anymore. Remove that and then remove the explicit storage there. And I removed that promise because it was extraneous. We don't need it. Really, the condition variable replaced that promise. As instead of polling with the future, we're polling with the condition variable, and we have two conditions, really. Condition variable is used for. And I renamed poll shutdown to worker. That's probably what it should have been called all along. And that was unrelated. Do I check that in next? Check this in first. So actually, this is unrelated, right? So unstage this. And this. This is all just making it asynchronous. They make diagnostic log printing asynchronous. Okay. Formatting and printing to a console, at least in Windows, incurs an enormous performance hit. Around 20 milliseconds per message. Have the worker thread handle these messages instead. Okay. And then all of this goes together. This is adding timestamps to all messages. Adding as le timestamps. Wait a minute. Oh, right. Timestamps aren't being printed if I run the realm server directly, but I hardly ever do that anymore, so maybe I don't care. But that's refactored out for now. Yeah, I'll just include that in. So, include timestamps in all diagnostic messages reported. I should maybe include the front end stuff with this, right? So I won't commit right away. Let me do the front end work. So let's run the cluster. This will reconnect to the cluster. Term 41. And then never did write the code to clear this out. I have to actually refresh that to clear that out to get the current log, right? Or maybe I did do that. Anyway, here's the log, but we're not seeing timestamps here. I want to see timestamps, dang it. Let's add them. That's the front end and the admin tool. And that is what, on diagnostic message or something? Or diag? Yes. And there's diag and there's diag batch. So right, I had this message, right? So it's in the message. So it's really just in the rendering of it. Wowee, look who's here. How's it going, Ramy? All right, so it's all the information is there. Let me verify that. I can see that in my React, right? If I look at my React state, I should actually have the messages here. Any one of them. What's it doing? It's receiving more and more messages, right? So it's always reloading that. Actually, why is it doing that? It should only do that if it's receiving more messages. Am I receiving more messages? I don't know. Let me refresh to see that. It's polling the cluster state with stats, but those aren't in the... Oh, the state is changing, and it's just resetting the whole thing, right? That part of the state is not changing, but this is just a bug with Chrome. So how would I fix that? Anyway, I can see that there are timestamps in there. It's hard to see them. I guess I could do this with the console, right? I would say there's a trick, right? r.state.log, yeah, log dot or reference 10 reference 0. Just look at it. Yeah. So we have timestamps in all the messages. So just need to format them. Was this it? That's not quite right. I'm doing okay, Ramy. No, there's a row render log message. That's right. That's how this thing worked. And here it is. So where do I want to put the timestamp? In front, I guess. So right here. And here, my knowledge doesn't help me out because I don't actually know the best way to format a timestamp in JavaScript. How do we do it? Let's ask Stack Overflow. Actually, that's exactly the format I want. Date.js. This is what, 7 years old advice? That's probably something better now. Let's look up a latest one. You see, this is 9 years old. Why do they do this? Someone asks it last year, and they say, oh, look, it's already been answered 9 years ago. Like, I know it's been answered 9 years ago, but is that really is that information still current? Yeah, exactly. This answer was written in 2010. This is the problem with Stack Overflow, right? When you have information that changes. Oh, for if I want a breakpoint, yeah. I don't want a breakpoint. What I want to do right now is get a timestamp. Is this what you do? To locale string? To locale date string? It seems awfully complicated. Really, I'm the only realistically I'm the only one who's going to be using this, so I don't really need to do it for any locale. I want exactly like this one had. I want exactly that, but with a dot and then so. What do I do? Maybe just use date.js like they did 7 years ago. Is it up to date? Like 4 months old. Mostly been dormant. Steps have been taken to revive the project. Eh, 12,000 weekly downloads. Okay, there is a built-in date object. Maybe I should just look and see if that's what I need. MDN, please. It's like I've been here before. Here we go, methods. Getter setters to date string to ISO string. Actually, I like that. I like this. I'll just do this. So new date and I give it a number. Let's just try it out. So actually I can do that all in line, right? It would be new date log message dot timestamp to ISO string. See what I get. What happened? It's not working. I break it? I might have broken it. X that back out. Why is it not working right now? Disconnected. Why is it not connecting? Oh, yeah, I've run into this occasionally. It's because I'm using a self-signed certificate, and Chrome eventually will say, "You don't want to go to that website. It's not secure. Advanced, proceed." Now it should connect. There we go. So I'll put my code back in. See timestamps? Oh, look at that. I see timestamps. Like, I mean, it's a little bit funky because you have the Z for Zulu and then you have the T for time. Okay, this is not quite right though. 1970. I'm pretty sure it's not 1970 right now. So what's going on with these timestampies? Let's take that value. New date that. Okay, I guess it's confused, right? You guys have probably already told me. Hey there, Crumpet. How's it going? You guys should check out Red Rage Crumpet sometime. He's an artist and game dev on Twitch, and I watch his stream along with some of the other artist streams out there to try to pick up a thing or two about pixel art. Seem to remember it not being a hassle to go from epic time to human readable. Yeah, I'm pretty sure I can do it with this date object. I'm just not doing it right. There's an international date time format according to Mozilla. Potentially something like that. Yeah, I just want something. I think this will work if I just call a correct constructor. Right? What does the constructor take by default? Or where do they usually describe that? Calling with a regular function return a string rather than a date. Takes a value. The values are greater than blah blah. Unix timestamp, which is an integer value number of seconds. Multiply it by 1,000. Oh, milliseconds. Yeah, you're right. So let me try that. This is why we have the console, right? I can just move the decimal point 3 places over. Yep, that's it. So multiply by 1,000. So Postal Rat got it. And that's an interesting bug. There we go. If I wanted to show it in my local time zone, it's a little bit different, right? I guess I don't care. I just want some stamp that I can always look for reference to see where is UTC. And it's like, okay, UTC, it's 2000 hours. Is that how you say it? 2000 hours. So that's the current hour. Yeah, that's good enough. And it is showing me the microseconds correctly, milliseconds correctly. Not showing me microseconds. It's showing me milliseconds. That's probably good enough, right? I can say all of these things happened within a millisecond, which is good. Cool. I can look at any server and see that. I can actually see which server. I was thinking about this earlier. Do I want to have a collated log like I do on the console here? This is all collated. And actually, now that we're printing out the timestamps, we can kind of see where they go out of order sometimes, I bet. Those all happen to be in order. It's probably because I'm using a release build. With debug build, you have a lot of weird delays. But I could play around with this. Let's add another server. Do something that's complicated. Localhost, we'll add a server 13. Give it some unique port numbers and say add. I'm going to do a bunch of stuff to add a new server. Maybe I don't need to worry about sorting. Oh, no, there's one case. See that? 12 actually reported that earlier by 85 milliseconds before that, but they arrived out of order. So that was the next thing I was going to do today was when we receive these messages, sort them by timestamp and then print them in sorted order, because occasionally they do come out of order, and I'm worried about that confusing me when I'm looking at these diagnostic logs. Here's another one where it came out of order. Not that it mattered much. You don't think there's much you can do about them coming slightly out of order? Yeah, I'm going to sort them. Where did I learn this? I have a little command with some information about where I learned this. Most of it was on the job, self-taught stuff. I worked at a company which was not really a software company, but they needed software people, and I was self-taught already, and so had a lot of the things they needed to know. This is a long time ago. If I were to start today, it would be a much different story. There's a lot more. Well, for one thing, there's the internet now. There wasn't an internet when I started learning programming. So there's a lot more resources. You young kids, you have it so good these days. Back in my day, yeah, it was books from the library to learn programming. So if you were to learn this now, there's a lot of online resources for this kind of thing. Yeah. My knowledge is constantly changing, though. A lot of things that I learned like 20 years ago, completely different now. Like C++, totally different language. I had to unlearn a lot of bad habits to learn the new stuff. All right, anyway. You could add a little flag to the output string that one has the earlier timestamp. I don't really care the arrival order, although I am showing that here, right? So you can see that we're printing the timestamp of when we actually got it versus when it was generated. And you can see the delay it took. It takes some of these messages up to upwards of 400 milliseconds or 450 milliseconds to get all the way through the system. And you can see that the arrival order is different. So I still have the information there, I think, but I want to sort them to see. I want to see it in the natural order in which they happened. I don't really care so much for when they received, but I have that information on the left if I wanted it. You're surprised. You mean by the fact that they come out of order? These are like 4 different programs with varying delays, right? It's not so much that the loopback address is quick, it's just I'm doing a lot of stuff like, can I show that here? In the network tab? No, I'd have to reload it. I can reload it, why not? All of these messages, for example, can be batched, so it could be that they happened before and then we're just connecting now. Actually, I'm not sure why that's only has 1 in the batch. Oh, because a lot of stuff has been, like, the buffer's been cleared out by then. Anyway, the messages themselves, there's a lot of formatting that goes into the message before it's transmitted, and then you have to, like, reverse it when you receive it. So I'm not quite surprised that this messaging stuff can have delays. Also, I think these happened right when where was it? I already lost it. Where were the messages that are out of order? I already lost it. Anyway, wherever they were, there's some unoptimized code that's being run, right? Or it's optimized by the compiler, but I haven't done any performance measurement or improvement or any kind of optimization, hand optimization of any of this. So I'm not surprised if some things take a little bit of time. What my plan is to first get the game up and running, and then if there are lag or performance issues, I go find out where they are and address them then. If there's like 500 milliseconds lag in printing a diagnostic message, I don't really care unless that causes an issue for players, which probably won't. TCP guarantees order of messages along the same pipe, but right now you have to remember, I have 4 pipes. So my cluster has 4 machines in it. Where do I show that? Well, this is showing, yeah, this is actually the same number of servers I have now, right? 4. So there's 1, 2, 3, 4 pipes just to the orchestrator, not counting the pipes between the different servers. So it's only within 1 connection is the order guaranteed. The order of arrival of messages between 2 different pipes could be anything. What did you miss for the last 50 minutes? I got my diagnostic messages now to have timestamps of when they're generated and when they're received and printed. And I also had them updated here in the admin console. Kind of an ugly format, but all I really care about is that the information is there and I could retrieve it out if I need it. And also in the meanwhile, I've been studying the high resolution performance counter, how it relates to the wall clock, running into some surprising things. So this has been running for over 2 hours, and I expected these two clocks to drift apart, but they're not. And I'm also running it on Linux to be sure, and yeah, they're staying locked, which is really weird. It kind of is giving me evidence that I don't really need to worry about using the high performance counter. I could just use the system clock. Maybe that's what I'll do next. I'll just use the system clock for my time measurement. So let me do that next. Let's check this code in though. This was code to show timestamps, right? So we're including the front end change now. Alrighty. Clean up some of the other files I have. Oh, right. I had some Linux fixes. So fetch get rebase origin master when we're done, and then push. And part pfth. And part pfth. I'm not sure what that means. Thanks for the follow, Forgotten186. Hopefully, now that you are following, you will not be forgotten. Can part of the problem be the TCP Nagel algorithm? You mean in terms of like how long it takes to message? I don't think so. I think it's just my code. I'm always going to blame my code first rather than TCP. Oh, I see. There's some confusion about what we were talking about. Got it. All right. Thanks for the follow, Murtiswe. Let me remove this old log file I don't need. I'm not going to remove Bob because I want Bob. All right. Yeah. Going back to my Trello. We're done with this. Set timestamps. Yeah, we're done. That's been done. Okay. We just did that. We offloaded the reporting of diagnostic log messages to another thread, so it doesn't hang up the orchestrator. We're still looking at the data for this, right? Or no, wait a minute. Yeah, let's address this by. It looks like at least on Windows and Linux, that standard chrono system clock is both precise and accurate to the internet. To what do we call it? Internet time? Internet time! I'll just use this. Rather than mucking around making my own clock. Alright. So we're going to do that next. Hey there, Murtiswe. I'm doing well too. Hope you guys are all doing well. Except we found out that Mr. Muffles is sick. So everyone, I hope, will join me in wishing Mr. Muffles speedy recovery. He ate something bad. Food poisoning. Maybe because they're both running NTP syncing in the background. Well, I think the NTP syncing is what caused this to happen. But it's a jump. It's not a frequency issue. I don't really care if the time jumps. What I do care about is if the frequency wanders away and my measurements become way, way off from real time. So if I just use the system clock, I'll expect to have occasional jumps where NTP syncs and like moves me around a little bit, but they'll only be occasional. They won't cause. Actually, what will they cause? They'll cause things to time out early, but hopefully only a few seconds at a time, right? This should be fine. Well, wait a minute. Maybe not. If we have a time jump of this long, 3 seconds, and I'm using the timekeeper for sub-second stuff, maybe I at least want to have a guard against that. By running on TCP no delay. TCP no. That's if it's a TCP problem, right? Let me capture that for later. I don't think I need to do that unless the lag I'm seeing is in TCP, but I'm pretty sure the lag I'm seeing is in my own code. And it's stuff I don't care about right now. I only really will care about it if it causes a problem in the game. Why did I close that? I just meant to minimize that. All right. Okay, 3-second jump in time. Not be good, right? Yeah, so ultimately, the time... Actually, wait a minute. The orchestrator and the realm server actually use different timekeepers right now. They happen to be the same code, but maybe what I should do is use this over 9,000 clock, which right now does the same thing. Let's do that. We'll have the orchestrator depend on 09K clock. And the realm server host as well. Over 9,000. Just me trying, that's my weird sense of humor. Okay, so we'll have this, instead of pulling that in, we'll have it pull in the 09K clock. Oh, hold on, before I do that, rerun CMake. Update all my IntelliSense. Now I can include 09K clock. We don't need time anymore, right? So this becomes very simple. We just have a clock here. And then we return it. Good time. There we go. That's one down. Actually, the other one's not far away, right? Down here. So now they're all funneling to the same class. Need to figure out how you want to do level generation. Yeah, I had the same thing. Rally Monkey was looking into that too. How to do a random or procedural generation of levels. And that's actually on my list as well. I had that on here too. Didn't I? Oh, maybe not. To put that on there. Research. That's more. This is to consider, right? Consider procedural generation, or best ways to use procedural generation to make levels. What category is this? I guess that would be one of these. Mapping. No, the mapping is for in the interface. Game state. Oh, you have code that generates a dungeon for pre-made rooms? Yeah, Rally Monkey was gonna try to do that too. I don't know if he's still here. There is a difference between looking for a solution and trying to make one yourself. I think Rally Monkey was trying to come up with one himself. So it would be sort of not cheating, but kind of might spoil the fun to look at another one. But thanks for the offer. How about if he or I get stuck, we'll take a look. It's kind of fun trying to figure stuff out on your own, and if you get, it's when you get frustrated or you really don't care to figure it out on your own that you look for other solutions. Okay, so this is, let's make sure this still works. Did this not, it shouldn't have built. Yeah, because this is running. Build, and then run. Nope, our sense of time hasn't lost track. So then the last thing I want to do for now is we're just going to use system clock. I'm not going to use any of this stuff. We're going to toss away. Yeah, we're not building Bob right now. We're going to toss away the system abstractions. Don't need that. Our clock is just going to be, we actually don't even need one, right? We are just going to return standard chrono system. I need to include chrono. System clock now. Oh, wait a minute. This is different, though. How do I get an actual time value from it? It's, oh, yeah. How was that done? There was a way to convert it into a value, right? To time t, or now? Now returns a time point. Yeah, but to time, I don't want seconds. I want high precision. So I don't exactly want that. It has lower precision. It'd be truncated, right? So if I want high precision, what do I do? Oh, what are these docs? These are ultimately from CPP reference. I should probably look at it there so you guys can see it too. CPP reference. System clock. This should be the same thing, only a little bit easier for you guys to read. So the now. It returns this weird thing called a time point. And if you compute their difference as a double, you get seconds. Someone must have tried to do this before. System clock to a Unix time milliseconds. There we go. That's Java. Oh, C++. Time point cast milliseconds. There we go. Time since epoch. Actually, that's what I want, right? I want to do time since epoch. Is that built in? So I can just do that. Hold on. Not return it. Const auto now equals that, and then we want to return is, already lost it. Duration cast, right? Double. Now minus, it's this. Hold on. It's the time point that has it? So it's what, now dot time since epoch? And then duration cast that? Like that? Okay, didn't like that. Why not? Sup, Brendan? Okay, it doesn't take what? What is this time since epoch? It gives me a duration. Oh, I need to give it that? Oh, no, I need a count, right? No, hold on. Let me think about this. It's that dot count, right? No, I'm missing something. Duration cast, no matching overload found. What does this mean? Could not deduce template argument for enabled. Yeah, the high resolution clock is that. I can look that up. That is not suitable because it is not locked to the internet time. It may be an alias to system clock, but it's like its requirements aren't quite right, right? Anyway, I want the system clock. So far, I've seen that. Oh, so I really do need to do. I wanted a double though. It doesn't want. I can't do. Let's do microseconds, and then divide by. I wanted as a float, a double. Will that work? Doesn't like that either. Cannot convert from. Oh, I need to do a count. I mean, that'll work. It's sort of ugly though. I would have liked to do double there directly, not have to do microseconds and then divide by a million. Yeah, it's kind of weird, but this is why I like to wrap it in other classes, so that I can, once I figure it out, I wrap it away, and now I just have a clock that gives me a time in seconds with fractional, right? Let me make sure that this worked. Like it works to me, because we're using it. Oh, right. We were looking at the difference between these times and these times before, and it might not have even been that they really were lagging. It might have been that the fractions from one program are not the same. There's no, the way I was computing them, it was just arbitrary reference points. So now they're not arbitrary. Now they're both from the same system, and now actually it's more realistic, right? So it's taking about 50 milliseconds for all of the processing of the message, all the formatting and unformatting, all that stuff, which is probably okay. And those timestamps look good in the front end. Yeah, look fine to me. We don't need server 13. You're gone. I love that I can like just blow away servers at a whim, and then I can add them back if I want. Other way around. Localhost 13, 8090, 8190. Add. Adding servers is a little bit more complicated. It has to join the cluster and all that. But it did. Replaying the log as it did, and we're cool. Remove it again. Okay, so I think I'll check that in. I'll call that work good enough for now. I'll still keep that around in case I want to play with it again. So we're using chrono system clock, microsecond resolution, time since epoch for our timekeeper. Use standard system clock, chrono system clock for timekeeping. And we'll say here, this was measured on both Windows and Linux and compared to both time from the C standard library and the performance counter which is query, what is it again? Query performance. Look it up. Source, Windows, time. Query performance counter. And what is it on Linux, by the way? What did I end up using? Clock real time. Linux. This was measured and compared to both, and with the observations that the frequency appears to match and the precision is at least as good, down to, what was it, around like 500 nanoseconds? That's good enough for me. I haven't tried this on the MacBook yet, though. What did I have? I checked something on the Linux side. What was it? Oh, the case. Okay, right. This is actually not going to merge correctly, will it? I get a merge conflict, which I'll go have to fix. Let's go fix the merge conflict. It's an easy one, right? So I can just do this in the editor here. Look at that. It even colorizes it correctly. What do I want to accept? I want to kind of take that. What was it? Lower. It needs to be lowercase, so use incoming change. Was it use incoming change I wanted? Oh, current change. I want the incoming change. Actually, what happens if I do both? Just does that. Okay, I don't want that. Incoming change, but I want to fix the case of it, right? Got it. All right. So commit that. Commit. I must apply a commit message. I had a commit message. What happened to it? It lost my commit message. Let me get it back. It was this. Wait a minute. What is it doing? This is just not showing me where I am. I'm confused. Oh, it's in the middle of rebasing. Yeah, fine. Oh, no, that's right. I don't want to do a commit. I want to do git rebase continue. Then now we're done, right? Yeah, I got confused. When you're in the middle of rebasing, you use the rebase thing to continue. Got it. Cool. All right, now we can push it. Time is complicated. I haven't even addressed this potential issue. This we saw with time. We'll probably see it with system clock, where time can just jump randomly. And I need to decide how I'm going to deal with that. Let me make a card for that. I don't know if I want to deal with it now or not. It's kind of hard to deal with without... I guess we could simulate it. Yeah, I guess it wouldn't be too bad. Let me make that another card. So this I'm going to be considered done, because it is frequency locked with real time. Let's make another card. Deal with sudden time shifts in 09K clock, and label that networking, because that's the origin of the problems, right? NTP or whatever is used by the system to synchronize the system clock to the internet. Can cause the system clock to jump either forwards or backwards. We need to deal with this to make our clock monotonic, like always increasing without ending up with large time offsets. So maybe I can do some Raimu art here to explain what I'm thinking. So we have this problem, right? Now if I take that and just take that picture out, I'll put this in OneNote here. Let me make a new note. This would be a server. Let's just make a new page. So this is thoughts or explanation about dealing with clock jumps. So we have that problem, right? So here we're going to do some drawing. Let's say our clock also is tracking that for a while. Then suddenly we see we're off. But we're off in a negative direction, right? So what we can do, instead of, if we were to jump back, now we've caused a problem, right? We could do that. But that's a problem in that during that time we're going back 3 seconds, and the clock will jump backwards. If we don't want that, what we can do is we know that the real time we're ahead by 3 seconds, but we can gradually slow down, right, until we meet up. And by gradual, I mean, let's say it's been 1/10 of a second between when let's say the time is sampled there and the time is sampled there, right? During this time, if that's 100 milliseconds, what we can do is, instead of, if this was 0, let me write it down here. If that's 0, and instead of saying 100, if we instead said 99, we have caught up by 1 millisecond to the actual time without appearing to jump back. So we can take that opportunity. If no one asks us for 3 seconds for what the time is, we can just immediately jump and say, well, no time has passed really, even though 3 seconds really did pass, as long as no one asks for the current time. But let's say someone does ask for the current time 100 milliseconds after the jump, we can say, yeah, well, 1 millisecond really happened, so now we've caught up by 99 milliseconds. And we can just continue that until we eventually converge with the real time again. And let's say instead of it jumping once, it jumped back. I'll use this color. Let's say it jumped back. Then we would adjust accordingly. If we've caught up that much, we would end up speeding up a little bit until we reach. So that's what I'm thinking about doing, where instead of doing sudden jumps, we do gradual shifting until we meet the system clock. And then our clock appears monotonic, but it was just that we fudge our frequency slightly. That's what I'm thinking about doing. So to simulate that, though, I need to set up like a test framework. Actually, what I need to do is let the system clock be mockable. Is that what we're going to do next? Or do I want to do this one? Sorting. Elastic clock, yeah. I think once an hour to prevent jumps. Yeah. Detect skips, like as in a leap second? It should. So if, like, let's say there was a leap second and our naive implementation didn't work with it, it would just be like a shift of 1 second. Is leap second always inserting a second, right? So it would appear like they jumped back a second. A leap second would look like the same thing that happened last night for me, only by 1 second and not 3. And then we would just slow down for a while until we caught up. Hey there, Endorn. I'm working on funky time stuff right now. So let's work on this. I have a test framework here for my 09K clock. Let's make use of it. Okay, I do need to make this mockable though. I can just keep it simple. We can have a function, right? We can have a function that, yeah, why don't I just do it this way? It will return a double. So we'll call it system clock, and then we'll just default it to be, doesn't capture anything, and it just does this. Right? And we will just return impulse system clock. How come I didn't like that? Oh, because this needs to be like that. Time and keeping. Yeah, I did all the diagnostic stuff I felt like doing today. All right. I'm working more on timekeeping stuff, which is more like what I used to do in my last job, which was kind of fun. So that should not have broken anything, right? Yeah, nothing broke. Nothing to see here. Everything still works. We got timestamps, which are actually pretty nice to see now. And now it's mockable because all I need to do is add another interface here. Like, do I want to separate the interfaces? Maybe I want to do that. No, actually, I don't think I need it. We'll just add a method called void set system clock. Standard function double system clock. Set the function used to sample the system time param system clock. This is the, I'm bad with typing today. This is the function to call in order to sample the system time. It should return the number of seconds since the Unix epoch, which is midnight UTC January 1, 1970. Period. What was the challenge implementing this time thing? The challenge is, well, the first challenge was I thought that, hold on. I should just keep this window open. For high precision time measurements, I was using query performance timer, query performance counter on Windows, and on Linux I'm using clock real time. I just made the assumption that from what limited information I thought I knew, that this was sampling a crystal oscillator in the CPU that has no correlation in frequency, like it's not locked at all to the internet time, right? But what I was finding with real performance, with real measurements, it's not drifting at all. I expected it to drift from the, I expected the wall clock time to drift from that high precision performance counter, and it's not at all. So I was wrong about that. I don't know why. So I shifted to using the system time, the wall clock directly. But one thing I did observe running this for a while last night was that there was a jump, which I'm not surprised. If my computer's time, when it synchronizes through NTP or some other mechanism to internet time, it'll sometimes jump, right? Usually it just adjusts its frequency and so it doesn't need to jump, but for some reason it had to jump by 3 seconds at some point. So I need to deal with that, because if I'm using very high precision timers, like let's say I have something that's queued to happen in 100 milliseconds, if there's a sudden time jump, then it's going to throw the timing way off. So my proposed solution is I will have something that tries to track that, but instead of jumping, it will gradually slow down or speed up as needed to match. And we'll do that through trickery. Like if no one asks the clock what time it is for 100 milliseconds, we can say, instead of it being 100 milliseconds advanced, we can say, oh, only one millisecond happened. and then we can basically skip 99 milliseconds closer to the real time. So that's what I'm trying to model now in a test. So here's the way we're going to mock the time, and I have to put it here. The smear, yeah. Well, but if you do it gradually, like if you it's not, there are problems if you have clocks jump backwards, right? Real bad problems. So I'm just trying to make a clock that's monotonic, as in it's always increasing forward. But there's no frequency guarantee, because I don't actually need a frequency guarantee at that level for my game. I just need it to not go backwards. Although if I wanted a frequency guarantee, I could make it like only adjust a certain percentage at a time, right? Like I could limit it to 1% change. So if it jumped a second, it would take 2 minutes to catch up. Should not use absolute time, but relative time. I'm using, okay, this is the first time I needed relative time. I wanted to correlate the logs from three different servers. So messages come in from 3 different servers, and I wanted to make sure that the timestamps can be correlated. So I can know that server 10 really was faster by exactly 400 milliseconds in this case, right? And that server 12 was another 180 milliseconds behind that one. So I need absolute time because these 3 servers are running in 3 different programs. They need a common reference. So I might as well use absolute time for the reference. I guess the alternative would be if the orchestrator starts up all 3, it could simultaneously send all 3 a message saying, reset your clock now. And then as long as they arrive at the same time, it should be good enough. But then this is just simpler. Simpler to use absolute time for this, I think. Get tick count. Yeah, but if my 3 servers are all running on 3 different machines, their tick counts will be different. So yeah, it's not going to be needed by the client really. It's only needed to correlate servers together. Okay, so this is easy. We just say system clock. How come this? Oh, because it's not scoped. Equals system clock. All right, now it's mockable, so I can what was I doing here? Oh, I was making sure that it's precise and that it matches the C standard library time function. That's what I was doing. All right, I'm testing it against time and against my high precision counter. Do those still pass? They should. No? Is this, oh, I have it running for 10 seconds? What's wrong here? Difference between them. Oh, I had it a ridiculous constraint just so I could see that. Let me fix that. So low precision, they should be within 1 second, right? And this, I was saying I just need microsecond precision. What can't be built? Function is not a member. Oh, it's not? Because I need to include functional. Which means I don't really need to include it here anymore. Oh, it's not precise within a microsecond? Huh. Why does it take so long to run? That one I understand takes 10 seconds. So I can't get to the microsecond. Well, about 10 microseconds. Back off our constraints until it passes, right? So it matches the performance counter within 10 microseconds. Realistically, I only really care to the millisecond. Anyway, we'll make the new test now. So handle sudden time jump backwards. So here I need to simulate it. So why is it not like that? What's the deal? Now it does. Set system clock. So this will be, let's make a now. And I need a reference. Return now, right? Now we have time mocked. So the sudden time jump backwards would be, we ask it what the time is. So const auto measure 1 equals get time. Actually, let's have it start at 10. And then we have the time go back a second, right? And then we should measure it again. And then let's have it move forward by 1.1. So what do I expect the measurements to be? So 10 should be measure 1, right? But what are measure 2 and 3? So if it, right now, it would be 9 and then 10.1. But I don't want it to go backwards. So what I think what I'm going to do is I have to pick minimum interval. And a minimum amount that I allow it to go forwards. How about just a millisecond? And then when it gets to here, we can jump. Should we allow it to jump forwards? No, let's not let it jump forwards. Let's let it only jump. This is really time jumps. Actually, I won't even know if it jumped forward, will I? Oh, unless I have two clocks and I compare them. The system clocks, are they mono... Hold on, let me think. Let me look this up. Steady clock. Monotonic clock that will never be adjusted. Actually, that's what we want, right? We want to compare steady clock to system clock. Not related to wall clock time. Is most suitable for measuring intervals. Yeah, so let's mock the steady clock too. This function is used to... Oh, thanks for the follow-on look. To sample a monotonic, a sample time in a way guaranteed to be monotonic, but not necessarily related to system time. This is monotonic time, right? What do they call it? Steady time, steady clock. This is the function to call in order to sample this. It should return the number of seconds elapsed since an arbitrary point in time, which only stays the same. What's the guarantee exactly? They don't really say. Oh, here we go. They say example it could be time since last reboot. It's only so really, and it's while it's constructed, right? As long as the function exists, because we're passing in a function. Steady clock. Okay. I didn't document these. That's really just copying from here. And this is steady clock. Does this actually work? I guess we'll find out. Whoops. Keyboard slips happening so frequently today. Okay. Steady clock. Let me actually see what happens if I do that in the real system. What kind of timestamps I get. I'm kind of curious. Yeah, I think it's boot time, right? That's probably how long I've had the machine booted up for. Actually, that's long. That's more than a day. And I booted up this morning. So it's some arbitrary point in the past. So what I'm thinking about doing is base our time off of an initial sampling of the system clock and then just use the steady clock. And then, so this is a little bit, the test is a little bit different. So now, how about let's call now system and then now steady. So let's see, it jumps ahead by a second, but only 1/10 of a second happened in each of these times, right? So I guess what I'll do is I'll set a constraint or expectation on how far, and this should be near, not equal. It's hard. It's very difficult to do an exact thing with floating point numbers. Okay, so if only 1/10 of a second passed, let's say we'll allow a 1% shift. So it should say, if we're going back, it'll be, instead of that, it will be 0.99, right? 1%? No. 1% of 0.1, right? And then when we move forward, we'll allow it, it'll be accelerating the other direction. So instead of what it would have done, which is that, we'll allow it to go 10% of that interval forward. So 2.001, right? Yeah, let's do it that way. So it'll basically either be slowing down, it's staying the same, slowing down, or speeding up, depending on if the system clock jumps. jumps away from where it should be. And we'll use the steady clock to measure, to detect if the system clock jumped and how far away it is. That test's going to fail, right? Actually, it's because I hosed it. This should be system clock. Run them all. Hey there, Shake Soda. How's it going? Making a clock that doesn't jump right now, based off of system clock and steady clock. Shake that soda, exactly. Okay, so let's try to implement it. So I think what I'll do is whenever we set a clock or we're constructed, we will just reinitialize. So let's record double a clock difference. This is the difference between the system and steady clocks used to detect when the system time jumps. All right. Working on your art today. Cool. You usually use SDL's performance counters? Yeah, I want a monotonic clock, and I also want it to not jump too far forward or backward. I mean, it's not jump backwards at all, and not jump forwards too quickly. So I'm allowing a 1% change, sort of illustrated by this. When the steady clock moves forward 0.1, we only allow it to move 0.0001. 1% of 1.1. And it's slowing down because we have the system time lagging, and here we're having the system time speed up again. Actually, and this needs to be a 2, doesn't it? Otherwise it's going to actually match it again. Hold on, let me think about this. If that moves forward 0.1 and that moves back, the difference is going to be negative 1.1. And if that, then it's going to be still negative. So I need it to actually move a little bit further than that, right? So difference now 1.1, right? And then here we're going to, that difference is a positive 1.2, which is, how do I do this? It was like, I had a shortcut for this. Evaluate E. Couldn't evaluate that. Really? Can't evaluate that expression? Anyway, it's 0.1, right? As long as it's a positive difference, then we can... Actually, it doesn't matter, right? As long as the difference shifts the other way. No. It is the sum. So it needs to be positive for us to accelerate. Right. Programmer art? Have you seen my programmer art? There's my Ramu art of the day. When we have a clock jump backwards by 3 seconds, we will slow our clock down until we match it. And if it jumps back forward, like it was a momentary blip, we'll have decelerated and then we'll accelerate back to match it. This is based on the chart that actually happened last night, where I was measuring the wall clock versus the performance counter, and it was tracking it really well until at one point it just jumped 3 seconds and stayed there. I was actually surprised the frequency was about the same. There was just an offset adjustment. Secretly a character artist. Okay, so I think I got that right. Okay, so there's an absolute difference we need to capture. But then there's like a gap that we need to account for, right? So I know what we'll have. It's going to be a offset. Well, offset and difference could be confused. How about we'll call it steady clock reference? Steady clock offset. And then output offset. Because this is the difference between those two clocks, and this is the difference between the system clock and the times that the 09K clock returns. Initially, no offset, but if we see, and then we'll sample that at the beginning, and then if we see a jump, then we will, oh, and that means I need a third thing, don't I? No, what I do is I update the output offset, and we try to slowly adjust it down, right? Every time it's sampled. So I'll need to record the last sample of the steady clock. Last steady clock sample. This is the time reported last by the steady clock. Okay. So we need a method that resets everything. Measure the difference between the steady clock and the system clock, and reset the output offset. So this I'm going to do in the construction, and also if either of these are set, which we'll always do this before we start measuring time anyway. So it should be fine. It's fine. This is fine, right? Void reset. Okay. So steady clock offset equals system clock minus steady clock. Could be negative, but it should be positive, right? Because we're seeing that the steady clock is much smaller values than Unix time. So, and then output offset is 0. And I can just sample it again, right? How come it didn't like that? No, it's temporary. Last steady clock, we'll just sample it again. All right, so the trick will be to sample them both. System time equals system clock, impulse system clock. And then steady time. It's very important that these execute very quickly together. And if they don't, the harm would be a momentary jitter in our own clock, which I guess is okay. So const auto interval since last sample equals steady time minus impl last, and then we're going to want to update that one. So this interval gives us our upper, like how much we're allowed to adjust. So we say, let's also measure a steady time, a system time jump equals, well, first let's measure now, which is a system time plus the output offset. Right? No. It should, we're going to base it off of steady time, right? So it will be the last, so let's update this later. It's steady time plus the Steady clock offset. So that gets us a time in relative to the system time. So the system time jump will be system time minus now. That's how much we jumped. Actually, that's what I want for output offset, isn't it? No, wait a minute. We want output offset to move towards the time jump. Yes. So if absolute, okay, I need math for this. Need math, quick math. How much reliance do you have on the wall time anyway? I just kind of wanted to track it in frequency, or I want to track. The wall time. I want to track wall time's offset. So I want it to correlate to internet time. Like if I run this for a year, I don't want this to be off by seconds, right? But the wall clock time is going to adjust as needed, and it's not going to be monotonically adjusting, right? Could be jumping backwards, jumping forwards. So for small intervals, I wanted to use a monotonic clock, so a steady time, right? Never had to do these corrections since ticking forward with a monotonic clock has been sufficient. Yeah, but I kind of want to. I guess I have the bar pretty high. I want it to not jump forward or backwards. I don't want it to jump backwards at all. And when it jumps forwards, if it's not precisely the monotonic clock's interval, it'll be no more than 1% out of range of it. So here, I'm going to say if the absolute value of the system, it's not a jump. It's really system offset. System clock offset. Well, it's really our target. Target offset. Because our target is the system time. And if what we measured is off, yeah, so if it's the target offset minus our output offset, if we're within, I need to define this. Let's hard code it for now, I guess. %1 of the, so it's that. Divided by the interval since last sample. This will be tolerance. Then we're just going to return now. Actually, we're always going to return now, right? No, we return. Okay, hold on. If it's above tolerance, we're going to do something. Otherwise, we're always going to return now plus output offset. Right? That's impl arrow. And tolerance, let's just declare that at the top. I want it to be 1%, so that's that, right? This is the ratio. Well, it's not a percentage value, right? It's, what do you call the thing? Like, if it's not a percent, it's not 1%, it's 0.01. It's a ratio, right? This is the ratio of how fast or slow the output clock can be relative to the steady clock. That's the best I can come up with it. Factor, threshold, yeah. I'll call it tolerance for now, until I come up with a better word. I'm not sure about factor or threshold or any word. We'll just keep it the way it is. If it's out of tolerance, then we're going to have to adjust it, right? either forwards or backwards. If target offset is greater than output offset, we're going to adjust it backwards. Simple output plus equals interval divided times tolerance. Otherwise, it's subtracting. Let's see if I got it right. YOLO. Got it wrong. Okay, how far am I wrong? 71. Wait a minute, it was returning 0? What? It should have been returning that. What did I get wrong? Oh, I need to add something, don't I? No, I add steady clock offset. Oh, I never called reset here. That's why. And I should go ahead and call them here. There we go. Maybe that was it. No. We're closer, though. 72. So I got the first measurement correct. What's the second one? 10.099. I'm off by a factor of 10. Is that right? So it's a tenth of a second. 1/100th of that. I think I am off by an order of magnitude, right? Is that better? I think so, right? Instead of a tenth, it should be a thousandth. Yeah. Okay. Hey, look at that. I should also test if it increases correctly, right? So if they both increase by some amount, and I can use some not arbitrary amount, difference is still that. Actually, it'll continue to slow down. I mean, speed up, right? Yeah, I want to model when it catches up. So it'll only catch up by, well, if I let it advance a long time, it'll catch up, right? Let's have it go 100 seconds without changing frequency again. So there's still a difference, but it should catch up to it, right? So that should be, it'll account for the difference by adding 0.1 to that. So it'll be 110.3, right? What did I get wrong? That should be a 4. All right, let's try it. No. 110.201. That moved it back to 9. And then it moves to 10.3. 110.3, right? What did I get wrong? Why is it not adjusting all the way? Let's see what happens when we get here. Step into that. Okay. Whoops. Oh, I don't have this built for debug. Debug build will take 10 minutes unless I hamstring the dictionary stuff, right? Oh, let's just do it. But I'm going to do this. If I build now, it's going to want to rebuild this, which takes 5 minutes to build. If I just temporarily take it out, it won't be able to link the other program, but that's okay. I'll just run the test I want it to run. Yeah, this'll work. This is fine. This is fine. Instead of taking 5 minutes, it'll only take 30 seconds. But it will not be able to link certain things, which is fine with me. As long as it builds everything else. Okay, that's fine. It's all fine here. We're all fine. So debug into that. All right. Cool. So system time is 110.3. The clock offset is 10. Is that right? It started out at 10. Yeah, trying to do it fancy. Fancy dancy with the debugger. So it's a long interval. Okay, target offset 0.09. Oh no, that's just 0.1. That's just 0.1. Hey there, Blueberry King. I'm doing fancy clock stuff right now and getting it wrong. Hopefully I'll find out what I'm doing wrong soon. I think I got this backwards. I think I want to say it is less. I sometimes get multiplication and division backwards. What function is the clock required for? It's to try to attain this. So if the system clock jumps, which it will occasionally do, and it can go backwards, so it's not monotonic. I'm trying to make a clock which doesn't immediately jump back, but it just slows down until it meets that time. And if it jumps back forward, it'll slowly accelerate to meet the clock again. And I'm allowing it to do that within a certain tolerance. So it can speed up or slow down by 1% of the amount of time that elapsed since the last measure. So if you go 100 milliseconds and sample a clock, you're allowed to either slow down or speed up by 1 millisecond to try to approach the system clock again. So it's, instead of returning the system clock directly, it's using a monotonic clock and the system clock to catch these jumps and to like accelerate or decelerate to meet to match it eventually, but remain monotonic, which means it's derived from the steady clock and not the system clock. Here's the default steady and system clocks, by the way. It just uses standard chrono steady clock and system clock measured in microseconds. So yeah, I got this backwards, I think. So this absolute value between, that's the difference. Let me think about this. Target offset is what we want our offset output offset to be. Isn't it? No, it's not. What's the purpose? Is to try to make a monotonic clock that measures real time. In order to, I use clocks a lot in my code to measure intervals, and I want it to be, the frequency to be pretty stable, but actually track real time. And real time does jump around because you're Your computer's clock is not always locked to the internet time. It's slightly off because of temperature, might be a cheap clock, whatever. But protocols like NTP will bring your clock back into alignment with the internet by doing adjustments like that occasionally. I'm trying to make sure that in my server code that we don't see, I don't ever want to see the clock move backwards. That would break a monotonic clock guarantee. And so instead of jumping backwards, we'll have the clock slow down until it meets, until the clock is correct again. And then if it jumps forwards, I don't want it to jump forwards because that would throw off timing for other things. Instead, I want the clock to slowly accelerate. So this is the acceleration, that's the deceleration in order to match things. How am I computing target? It's system time minus, oh, right. This, so we want our output offset to meet the target offset. The offset starts at, actually, what's this? Okay, the steady, there's an initial steady clock offset, we add that in. I wonder if it'd be simpler to just make the output offset be that to begin with. It wouldn't it make sense to just get rid of this steady clock offset and make our output offset be that? And then I don't need to add that. Yeah, I think that would be work. Would this have been useful for Adam's problem? I don't know. What was Adam's problem? Yeah, I'm still off on my math here. Let me think about this. So if I think I actually want to multiply by this. So let's say it's 1. Then we allow it, then we will adjust it as long as the difference didn't shift. The difference isn't more than 1/100th of a second. If it's within 1/100th of a second, we can't adjust. So we just keep it the same, right? Just make a guess and see if it passes my test. No. Oh, wait a minute. Why is it still debugging? Is that why it wasn't changing? No. Hey. Okay, I'm gonna say your name wrong. I apologize, but thank you for the raid. IFO and Croft. Hope I got it close. So what were you streaming today? I haven't actually seen your stream before, I don't think. I need to follow you. Let me is there a /follow command? No, there isn't. How would I do this? Oh, now that you've said something, I can follow you. There we go. It's pronounced different, so it's not I. IFO and Craft? Anyway, what were you streaming today? Welcome, raiders. I'm working on making a clock that doesn't jump around like the real-time clock, like the wall clocks does sometimes. This is actual measurements I made last night, tracking the difference between a performance counter, which is monotonic, and the wall clock. So at some point, the wall clock adjusted backwards 3 seconds because it was off from the internet time. And if I were to use a clock based off of this, we'd have a sudden time jump, which would throw off timing in my code. And so what I'm designing right now is just a simple clock that's monotonic, and instead of jumping like that, it just slows down until it gradually meets the real time again. And if it were to jump back, it would accelerate to meet it again. And so the clock I'm making as an output always moves forward, and at most it's 1% slower or 1% faster than real time in order to catch up or slow down to meet the wall clock. So that's what I'm trying to get right here. And this is all for a game I've been developing. I am making a game that is multiplayer, so I have servers and clients, and I have multiple servers, and so I need a clock like this to make sure I can correlate certain things between servers. The game exists as copies on numerous servers so that it's all replicated. So if any one server goes down, you lose the client's connection. The client can connect to another server and keep playing. And I use a log replication algorithm called Raft to implement that. And so, for example, you can see the cluster running here, and there's messages from all three servers, 10, 11, and 12. And I've just recently added these timestamps in here, and I want to make sure that the clock that I'm using is pretty good, and so these timestamps are matching both real time, like Unix time, and also are pretty precise. So I kind of want a mixture between, in C++, there's the steady clock and the system clock, which look like this. System clock can jump around. Steady clock is always monotonic, but is not tied to real Unix time. So I'm making a class that samples both and then returns an output that is based off of the steady time, but has an offset that can either be accelerate or decelerate until it matches the system time. That's what this is doing. But I have a bug here and I haven't figured it out yet. So if you have any questions, let me know. Otherwise, I'm going to keep debugging this. So target offset is 10, output offset, oh, okay, I can't put a breakpoint there. I need to put a breakpoint. I need to let it get to there and then go into here. Okay, so target offset's at 10.1. Current offset is 10.001. But then 100 seconds has passed. So what is that? Maybe I should just do a watch thing here. What is 10.1 minus 10.001? And then what is that? That's 0.1. No, 0.099 times 100. Okay, so it should go into that if, right. That means we have to accelerate. But we accelerate by how much? Oh, it went too far. Oh, it accelerated too far. We need to have it stop if it gets to it. Right, okay. So it should go no further than the target offset. Got it. So really this is we need to clamp it, right? Standard minimum of that, this plus that, and the target offset. And then this will have a similar problem, right? So that's algorithm. Yeah, so the Raft consensus algorithm was pretty fun to implement. And it is something designed by Diego Ongaro. It was his PhD thesis, and it was Adam13531, another Twitch streamer, who recommended I look into that for... my goal was to make the game so that if any server goes down, we don't lose any state, and that consensus algorithm was designed for exactly that purpose, for fault tolerance. So this is going to be that minus, and this is going to be an equal. And again, target offset is where we cap it to. Let me see if that works. Yeah, that's because I don't want to rebuild part of my project because it would take 5 minutes. Although by now I could have done it. Yay, it works. So in case you're wondering, I'm using test-driven development. And I'm using the Google Test Framework, and I'm also using CMake, and I'm using a bunch of extensions actually in VS Code to do this. So what I started with was this unit test, which describes the scenario, and we have mocked the clocks involved so to demonstrate the problem. So what we want to happen, right? I want to have these measurements monotonic. See, they're always increasing, they're not jumping back, and they're also not jumping forward too quickly. And so the scenario is the system clock starts at 10, steady is at 0. They don't necessarily have the same reference point, right? System is the Unix epoch, January 1st, 1970, midnight UTC, as every programmer should know. Just kidding. And steady clock has an arbitrary reference. So we measure the time. It should give us the system time, right? And then here we're pretending that the system time actually jumps back to 9, but the monotonic clock, so really the interval was 1/10 of a second, but the system time jumped back. So the difference is that minus 1.1, right? When we measure it, we don't want to see 9.0. We'll end up getting 9.099. So instead of 10.1, it's in its slow down mode because the difference is negative. And then measure 3 here, we simulate that it jumped back, and now the difference is a positive difference. So it kind of flipped back the other way, right? And so instead of getting 10.199, we expect not 10.2, but 10.201 because it's trying to accelerate to match 10.3, right? And then I have it just advance both clocks by 100, so there's no jump. We just let time a lot of time elapse to see where it settles at. It should settle at that difference of it's not still that. Well, it's the difference is that, so it should go to that. Yes. It should what we want it to do is stop accelerating when it meets the system time again. That's why I have that number in both places. So yeah, so TDD is all about writing the test first and then seeing that it fails, which we have with the little green and red. It's red if it fails. And then we go and update the code until we get the test to pass. And then I can run all the tests to make sure I didn't break anything. The long interval is 10 seconds. So I'm actually, for the real-time measurements, I'm not mocking anything. I'm actually using real clocks. For the low precision, I'm using time from the C standard library. For high precision, I'm using a performance counter, which I have abstracted away in this class. So in this one, in Windows here, it's using query performance counter. And for Linux, it is using clock real time. What am I using for Mac, actually? For Mac, I'm using mock absolute time. And you use time-based info to get the scale. But yeah, I believe these are all derived somehow from either a disciplined high-performance counter or from the performance counter in the CPU, which I didn't think had the same frequency as... I didn't think it was frequency locked at all to the wall clock, but I've been measuring that all day now, and it's staying so. So I kind of gave up on using the performance counter. Actually, I switched to using the facilities from C++, system clock, but knowing that it's not monotonic, I'm using steady clock now to discipline it through this offset. And capping the acceleration to a certain tolerance value. So we speed up or slow down at no more than 1% of the rate of the clock. If I got this right. I think I did. So I have like 5 minutes left before I usually stop streaming. My schedule is from 10 a.m. to 2 p.m. Pacific, so I'll go a few more minutes. But I'm actually reaching the end of this task, so it's maybe a good stopping point. I've been using Trello, by the way, to mark my tasks, and I also have the today command will bring you to, I keep my plans in OneNote. So like the night before, I'll make a plan about what I want to work on, and I'll put up the same kind of information in my Trello. And we just did that. We dealt with sudden time shifts. And if you don't get the reference 09K, it's over 9,000. This clock is over 9,000 kind of a clock. Silly name, but that's okay. I am not going to get to that today because that's going to take me too much time. But this is what I worked on today. This is kind of the scope of what I get done in 4 hours. I do like 3 or 4 tasks. And these are all like ant steps climbing a mountain. Where the peak of the mountain will be, I have a game. Actually, I can spend the last 5 minutes. After I check in this code, I'll show you a little mock-up I made, demonstrating a little bit of the look and feel, graphics-wise, and how the game is broken up between client and server. Looks like I had this ready to go. I just did not... Oh no, this is an old commit message. I had that pasted for some reason. Right, so there are 3 things and 2 things involved in this change, right? So ultimately the summary should be make 09K clock monotonic and relatively stable frequency-wise, right? So to do this, use both system clock and steady clock from the C++ standard library. Base output clock measurements on the frequency of steady clock, but make the reference the system clock. Accelerate I'm getting these wrong. How do you spell accelerate and decelerate? That doesn't look right. Maybe it's two L's. The output clock to make it chase the system clock within 1%, or at most 1% frequency difference. And that's about it, right? Oh, also make system and steady clocks mockable for testing. That was doing it this approach, where we can set a new function to measure either the steady or the system clock, which I used in the tests here. That's how you mock time. You just say, yeah, what time is it now? It's whatever I have in my variable. Thank you very much. So if you're interested in taking a look at this or critiquing it or improving on it or whatever, just reusing it, you can check it out on my GitHub. This is 09K clock. And let me fix this modification. I hacked the, let's put this back to release build. I hacked my make file for a second to turn off building this one component that would take 5 minutes, because I don't want everyone to wait. We're going to build a release build. I'm going to check this in, and I'll give a brief little demo. So we added 09K clock as a dependency to the rest of my system. My mouse froze there for a second, and I dropped a bunch of frames. That was weird. Oof. Dropped frames. Dropping frames. Sorry. Hold on. I need to make sure I don't have a runaway CMake. This happens sometimes. If I do, I'm going to have to kill it. I know we're good. Well, occasionally I have CMake just run away allocating memory, and then I have to reboot my computer if I don't kill CMake fast enough. But I think we good. So, right, I switched from using my performance counter and time and doing this low budget clock to using 09K clock. Use 09K clock for timekeeping in the game. All right. Just add a make J10 on a 4-core machine. You start dropping frames. Yeah, I don't usually drop frames when I do that. But then again, I don't normally build everything. Why can't it build something? Am I running one of these servers? Nope. What's the problem? Let's build again, see what the problem is. Well, that's weird. The tools are kind of weird on me sometimes. They'll fail, and you run them again, and they succeed. It doesn't happen often enough for me to really be interested in tracking it down. I just chalk it up to be a temporary problem. You're my voluntary investment program. Yeah, I see. VIP. Voluntary intern partnership, or partner. Voluntary intern partner? Does that mean I can assign you work, NPerry? Yeah, I get these problems writing the manifests to the programs it's building, and when I just rebuild again, it'll just work. Access denied. Oh, I wonder if I have a zombie process. Let me look. Do I have a zombie? I don't see anything. Why can't it well, I just have to blow it away, maybe. It can't build that unit test, so delete it, right? Delete build realm server test, realm server test. There we go. We blew it away. Rebuild it. There we go. It's passing now. Let me run my little demo. I did this mock-up in about a week, and it's illustrating two things. My understanding of entity component systems, because I'd never made one before, and a look and feel about how the graphics might be when I first start up. And also, I can use it now to demonstrate the communication style between server and client that I've been using. So this is the front end to the game. And so the real game I'm developing will have the same kind of front end. You'll play the game in the browser, or it might be on your phone, and you'll control a character, and you'll run through a world. And the story, I haven't designed it yet. This mock-up is just based off of a simple game called Gauntlet, which was made by Atari in the 80s, where you go around in a dungeon and you're fighting monsters, you're collecting treasure, the exit gets you out to the next level. And the back end is all in C++ I have the capability of doing the game logic in Lua. Between them, I have a WebSocket. So every time something changes on screen, there's a message from the through the WebSocket from the back end that says what to change on screen. So here, for example, we're adding a sprite. And here we're just updating. I guess that's back. I guess these are extraneous. But here we reduced our health by 1 because hunger causes our health to tick away. And messages in the other direction are sent whenever input changes. So I press K to move. I guess K is down. And then when I release the movement key, so those feed back into the input component for the hero, right? And the indie component system will either move the hero or not based off of if you're holding down a movement key or not. So that's pretty much, hopefully that's self-explanatory how that mechanism works. The real game I'm making will be the same way. You'll connect it to the server through a web-based app. It'll talk through WebSockets and sending any kind of input you give via a message to the server. Messages back from the server basically describe to the client what to draw on the screen. And the art style, because I'm not a great artist, I aim for something reachable by me, which is simple 2D pixel art, which I've been calling Raimu art because it's like Atom art, only it's by Raimu. Why so much communication with the server? Well, you want to have reasonably good frame rate, right? So this game's frame rate is 10 FPS. So at most, there will be 10 messages per second, right? Every game tick, you might have something change. The sizes of the messages are pretty small, right? So it shouldn't be a problem. You just get a steady stream of bytes going to and from the server. They don't add up to that much. And they can aggregate. So if you have several messages between refreshes, you can accumulate them as one message. But yeah, you need a message from the server every time something changes because the game client is really just a dumb terminal. It doesn't do any of the game logic. It doesn't know where the ghosts moved, especially in multiplayer, right? You don't know what the other players are doing until the server tells you. The server is going to tell you through a message. How do I expect it to scale? I cringe when I think about it because there's two problems that might happen. One is a good problem, one is a bad problem. The good problem would be if lots of people try to play the game, that it doesn't scale very well at first because it's just too slow. And that problem I will try to solve by designing or making changes to the design to allow it to scale up. The one reason right off the top of my head would be I would separate the login servers from the game servers, right? Like what they do in real MMOs. So to offload the work of handling authentication, tokens, all that stuff, let some other server cluster do that, and then once you're logged in, you get handed off to the real game. That's the good problem. The bad problem would be that no one plays the game, and I don't need to scale, and I just don't make any money, and I have to go back and get a full-time job. So actually, I prefer to see the game have technical scalability issues because that means people are wanting to play it, and if I fix the technical issues, I can make this a living. So, what do I think will happen? Thinking positively, probably that I'll run into some performance problems, and I'll be working on them on stream. And I'll be trying to integrate my stream community with the game, so that you guys, everybody who's like a VIP right now, will probably be able to play the game for free forever. I'll just give you a free pass or whatever, and get feedback from you guys. You'll tell me what you like, what you don't like, what's good, what's bad, and I'll be adjusting the game and addressing scalability issues according to what people want. You got to go full MMORPG. You want to be a millionaire. Well, I just want to make enough money to not run out of money. So it doesn't have to be an MMORPG. I just need to get a certain threshold of people willing to pay for content. So if I actually get enough people interested in this, I'll probably hire an artist and spend money on marketing to continue the trend. I want to see a positive upward trend by the end of the year. Otherwise, I gotta go get a job. Think the character should get some shoes? Does he not have shoes? Oh yeah, you're right. He's got his well, it's scale male armor all the way down to his toes. Yeah, that my art, I did it in like 10 minutes or something, and I'm not an artist. What can I say? So anyway, the real game I'm trying to make, you can't, no one person can make World of Warcraft, for example. So you don't want to set your goal as a solo indie dev to be something, totally on that level. I'm shooting for a much lower bar, which is something simple that maybe is fun for us to play with, and maybe just get a minimum amount of interest in it and try to put as much time as I can into things I can do, which are the technical aspects, maybe the story, and if it is working out, I'll hire people to do the things I can't do as well, like the art. And work on the technical side of things that's what I would prefer to do. So anyway, I hope you enjoyed today. I'm not sure what I'll work on tomorrow. It kind of depends on if I feel like working on this, which is to get the messages in my main game sorted out. The main game looks like this. We start 3 servers. The servers process the log to catch up, and then we can access it through an admin console. We can see the status of all 3 servers. I can actually add a server if I want. This is using that consensus algorithm we talked about before. So I can say, I want a new server. I want it to use those port numbers. And then the cluster, with the orchestrator's help, will launch a new server. It joins the cluster as a follower. That's what the F means. 47 is the term number, so I've rebooted the cluster 47 times, essentially. And yeah, we can dynamically add and remove servers at will. And the most that a client will see is if they happen to be talking to server 13 there, they'll get disconnected and then they'll reconnect to one of the other servers in the cluster. So momentary pause, which I can even remove if we have a graceful handoff. If the act of removing a server is first have that server tell its clients, hey, go connect to that other guy because I'm about to leave, then the client wouldn't notice anything. Do you expect WebSockets to ever be a barrier to scaling? Yeah. So one piece of flexibility is that in these WebSockets, right now I'm using JSON text messages. If it turns out that my bottleneck is in the parsing, the construction, or the transmission of these text messages, one thing would be to use like protocol buffers, make these binary messages, because WebSockets support binary messages as well. And I can illustrate that. I already have a binary message that I use, is if I want to make a new package of the game. I haven't done this in a while, so maybe this is a good test. I need a console that's not being used, though. Console that's not being used. Let's go, and I have a script to do packaging. Make a zip file. So there is a 2 megabyte package that has the current game code in it, and I have a Python script under deployment, Candinal 1.0. So this talks to that same cluster, only it sends it as a binary message to the WebSocket. It's actually really fast. It does it in less than 20 milliseconds. And it takes another 80 milliseconds for it to be hashed again It's actually sent on to the orchestrator, hashed again and saved, and it appears back here as a version I can select. But yeah, that's using binary messages, and I found that it's plenty fast. 2 megabyte message only takes 20 milliseconds, so we're good, I think. That's one movement point. So if it turns out that I am sending lots and lots of messages, and even as binary, it's still slow, yeah, then I might be in trouble. We'll see. I could try. What I would probably end up doing is instead of sending like separate messages like this, I would batch them. I would have within a certain frame interval, perhaps every frame, you would just get an array of all the messages that happen during that frame as one message. Transmission faster than the unpacking? Probably. Although the unpacking is pretty fast too. I don't know. I haven't really measured all this stuff yet. Anyway, hope you enjoyed that. I don't know what I'll be working on tomorrow, but hopefully it'll be fun. Probably pick from my list here. I really need to think about it though after I eat some food, because I'd be a hungry programmer right now. So I'm gonna call it for now. Hope you guys enjoyed. I have a Discord, and what I do before every time I stream, usually the night before, I'll add a page to my notebook. So if you check out my notebook later, there'll be a 131 plan, and if not, I'll announce on my Discord like 15 minutes before I stream, like a little blurb on what I'm gonna do. That way you know if it's interesting to you or not, whether or not you want to join in. So I'm just going to off screen here. I'm glancing to see who is streaming, and we'll pick someone. There are 8 people I'm following that are streaming now. And it appears 3 of them are programmers. No, 4. 5. 6. Thanks for the follow, Imp MJA. Okay, how about Pocket Watch? That's an interesting stream. Can add to Andy's view count. So I'm gonna raid Pocket Watch. You may or may not have heard of this stream. It's a team of 2 programmers, or team of 2. One is more of a programmer, the other is more an artist, I think. And they're working together on a game which is an action RPG. And I believe it is built on Unreal or Unity. Actually, I'm not sure now. But it looks like Andy is working on it right now. He's showing off the game or working on something, so should be fun. I'm gonna go raid Pocket Watch if you don't mind. We'll all go say hi to Andy. Oh shoot. Hold on. I'm canceling it because I want to. Okay, I've changed my mind. There's someone else who I'd like to introduce you guys to. His name is Red Rampage Crumpet. I've been waiting for him to stream while I'm about to raid so that you guys can see him, because he's a new Twitch streamer. New Twitch streamers have this problem where people don't know about them, so they don't ever check out their stream. And he only has like 17 followers, so I'm going to rate him instead. He is working on art for a game in Unity. So sorry, Pocket Watch. We're going to raid Red Rampage Crumpet instead. How come it can't find it? Probably because it's not on my auto host list. I'll just type it in the command line here. There we go. So let's show Crumpet some love. He was on this channel earlier chatting, and we'll go surprise him with a little bit of a raid. Okay, I'll see you guys tomorrow morning. Have fun. Enjoy the rest of your day or evening, and see you later. Bye.